Good evening and welcome to the second of these workshops. Thank you for coming. I can see that we've got 12 people currently taking part, including the presenter Tom Gill. Today's is on value design, and we're in for another 3-hour marathon, so the day is on. The next of these sessions will be in 2 weeks' time, because at the beginning of May we have one of our regular SPA evening sessions. This one with Nick Tune, who's talking about working agile in distributed teams, which seems like a very opposite subject. So without further ado, I'm going to mute myself and drop off this talk and hand over to Tom.
Right, thank you, Evo. Welcome everybody. By the way, can you all see me and the screen? No, not getting an answer. Can see my screen at least. Okay, I can't hear a reply from Evo. Okay, so by the way, if anybody wants to follow the slides on their own other device, here's a link to the slides. You can photograph that screen or just pick it up later. It'll be on the last slide too. We are videoing this, and the videos for all the sessions are at this URL. And you want to complain or talk to me, there's my email, and there's Twitter, LinkedIn, and let's get going. Okay, so I hope
just
many
to answer your last question, we're getting questions in from people to say they can see you and they like your hat.
Right. Now, I have to explain, I'm sure that my friends, Chelsea supporters, will be most taken back by the Manchester United thing, but I have to explain I'm in Norway, and the manager of the Manchester United team is Solskjaer. And so everybody in Norway is a fan of Manchester United these days. That's the excuse for the cap. Let's see, what have we got? There's a little picture of 5 minutes walk from my flat here near Oslo in Norway, the Kolbotn water. And I just made a trip with my wife out to our summer cabin about a half an hour away on the Oslo fjord. And here's a picture of it. So this is where we quarantine, ha ha ha, places like this. And I even managed to take this today as I was out there. And there's the proof of that. So that's what I do when I'm preparing my slides or just getting away from it all or something like that. So you're going to see a lot of detail on a lot of slides. There are over 100. We'll somehow manage to get through almost all of them by 3 hours from now. However, if I want to summarize the whole thing in a nutshell, I could do this. Here is the functionality symbolically of any system, what it does. Here symbolically is any value requirement, anything like security, usability, any capability, performance, quality, that kind of thing. And this arrow represents more or less good there, more good there. This point here represents how bad our system is today, and this point on the arrow represents how good we want to be, how much better we want to be. We'll be talking a lot more about that during the talk, but we talked even more about it in the value requirements course, which you will find videoed at the video site. This rectangle, which is kind of squarish, represents a design impact, and the width of it represents the degree of impact. So what it means is this design idea is good enough to get us about halfway towards how good we want to be in, say, security or usability. So in other words, it's a way of quantitatively, in this case graphically, looking at how good is a design. It answers the question of how good is it for satisfying some value or a set of values. And that's what we're going to focus on this whole term. So in a way, if you say, how can I summarize the whole 3 hours of blah, blah, blah from Tom and some very busy, very detailed slides, you might like to get back to this one slide, and it's all about a design getting us from where we are to how good we want to be in some value or quality. That's it. That's all I'm going to say for about 3 hours. I was having a conversation with an American professor at a conference in Poland less than a year ago, and he pointed out to me that there is apparently no acknowledged general theory of design. And I started asking him, what does that mean? And in this paper, which you have access to, it gives his paper, and he explains what you have to do to have an approved, academically approved general theory of design. And I started noting that most of the requirements for having a general theory seem to be satisfied by my own method, which I call planguage, planning language, design language, if you like, but requirements and design language. And language is described thoroughly in a book you can have a free digital copy of to pay for your own paper copies, Competitive Engineering, right there. And anybody, especially academics, who might be listening to this, or somebody who just wants to go very, very deep, might have fun reading this paper where I assert that I have the requirements for a general theory of design, maybe the world's first. Anyway, 51-page paper. Have fun with that. Here is the content. Number one, the content is based on a book I drafted last summer at the summer cabin I just showed you a picture of, called Value Design. And you all get a free copy of that. Just for fun, since people don't appreciate what they get for free, I'm telling you the price of the book is actually 1,000 quid, and the value of the knowledge is at least £1 billion quid, just on the first large, say, national health or COVID-19 project. So don't confuse value of a set of ideas with the price of them, as Noel Coward commented on. Anyway, here's the syllabus for the book, and I've pretty much made these slides and this 3 hours to parallel the book. And so here are the 10 topics we're going to go through one by one. Now, here's an overview of the method, a value delivery cycle, we call it. It's similar in principle to a plan, do, study, act cycle of, say, Deming or Duran or Schubert. They all were involved in that. And we can start here and say we start with stakeholders. Notice I did not say customers or users, as you'd find, say, in Agile culture. I believe we need to do something much broader, and I talked about it more in the value requirements lectures. But stakeholders are maybe 50 different stakeholders, some of whom are customers, some of whom are users, and some of whom, like European Union privacy law, are not customers or users, but they still have requirements that must be satisfied by design. Anyway, get an overview of your stakeholders, say 50 of them, get an overview of their values, and not only identify value, like they care about security, but identify how much security of which type they want by when. And that is known as a value requirement. And that's what we spent 3 hours and the whole book talking about last time. We're going to give you a very short repetition of that to start this course off. Once you know the values you have to deliver and know when you have to deliver them, and maybe even something about how much it's worth to deliver them, like any possible budget, we need to go to what are called solutions here. Now, solutions are design, and solutions has many names like architecture, design, the means to deliver the ends, but they're just there in order to deliver us the value levels of, say, user friendliness or privacy or security or health or whatever we want. Okay, so we have to, now the solutions we find have to get to the levels we want by the time we need to get them there. Let's call it the deadline. If they don't, then we have to find better solutions or different solutions or something like that. So mainly this talk is primarily about the solutions. Let's just say we did this on the value requirements course 1 week ago on video. But we're also going to talk about decomposing the solutions, which are often big architectural ideas that would take a year or 2 or 3 to implement, into very much smaller ideas. Some of you might like to think about them as sprints, but I call them value delivery steps. And I like to think that they're about a week, maximum a month, maybe 2% of the budget, something like that. So decomposition is something we do so we can do Agile properly in step by step and deliver critical things early. We'll talk more about that. So the main part of the talk will be here today. So then the design work is done, and somebody can acquire or code or build or do whatever they do to get something ready. And when it's ready, they can deliver it, meaning integrate it step by step into the existing system or a new system you're building. We'll talk a bit about that during this talk, and then measure whether we actually achieved the values we hope to get from the design, and within the cost framework. There are many kinds of costs. We'll look at that in more detail. And if they did, fine, we learned that they did, and just keep on trucking, take the next step. But if we learn something negative, like the design doesn't work as advertised, doesn't give us the security we want or the user friendliness, then we have to, in a sense, go back to square one and find better designs and try them out and keep on doing that until we finally achieve what we want. So here's another view of the whole thing. This area here is a business analyst area, i.e. stakeholders and requirements. This area here, I call it architecture and design engineering, and that's our topic today. This area here is development or dev area, scrum area, that kind of thing. This area here, I haven't found a better name, I just call it reality. Find out what's really going on by measuring and analyzing and deciding what to do. So here I've placed in a little oval at the bottom our good friend Scrum or similar Agile methods. And my indirect point is these methods are not very strong on stakeholders, values, and they're actually very weak on designs and design. If you compare, now their excuse is, we're not weak on design, we're a framework, and if you require better design methods than just take a user story and convert it to code, then you'll have to plug in, for example, the methods I'm teaching you now can be plugged into. My good friend Jeff Sutherland, who co-invented Scrum, has very explicitly stated that these methods you're looking at are some of the most advanced methods he's ever seen in Scrum, and of course you're welcome to plug them into a Scrum framework to get more advanced. So here's your book. It's actually I have a copy of it here, but that's just, you can print your own copy, but it's not published anywhere. Publishers would be nice to have. Somebody's ready for that. Translations would be nice to have too. But right now, you all get a free digital copy, and it pretty much parallels our course here. And once you've been through the 3 hours here, you're definitely primed up to make use of the book. So, and here again is slide location for the slides we're using now. Again, if you want to take a quick photograph of that. Okay. Now here's a repetition of the 3-hour course we held last week, Value Requirements. And First ideas were operating here with stakeholders and values primarily. And here's symbolically some requirements or values, all numeric. Here are some costs, and let's call all of this requirements, and they are values we have. Now these values define failure and success. If you're trying to get to a certain level to succeed and you have a numeric level there, that defines success. If you have a minimum level you have to get to avoid failure, we call that a tolerable level. We have actually formally defined failure. So the numbers define failure and the numbers define success numerically. And we can change those numbers, they're not static, as we learn that we have to have higher levels to be competitive, for example. In the planning language, and again, this is still repetition of what we talked about last week. Here's a very simple example of security value with a scale of measure, which is the key idea of the value requirements. So percentage probability of detecting a hacker within 5 seconds, that's clearer than just saying, I want higher security, because I'm answering the question, what do you mean by security? And I say, it has to do with probability of detecting hackers within a certain time limit. And what's the situation today? We call this a benchmark. And well, we're only 10% probability of detecting a hacker within 5 seconds. Well, what's your non-failure level, your tolerable level, your worst acceptable case? And says, well, it's to get to 80% by the end of this year. So we've anything less than that, for example, 79% and below, is now defined as failure if we get to the end of the year and we don't have anything better. But what do we really want in our dreams? And we have a wish level, which is what the stakeholder dreams about before we've validated that we have designs or architecture to get there, which we can afford. And the wish level is 98%. When the designer concludes that they have architecture and can afford the architecture to get to 98% by the end of the year, we convert this wish to a goal, which is a formal way of saying the project has done its design work and you can be assured that you're going to get to 98%. We have the design and we have the money to pay for the design. So this, in a nutshell, is the requirements we're looking at as the input or the basis to any designer. We also took a deeper look at an advanced technique for writing scales of measure using scale parameters. And although this is primarily a requirements technique, we're going to actually use this to help us with the design and help us with the decomposition design. So we'll be back with this, but it basically says we can plug into our scale certain general types of things like attack types, effects, and stakeholders, and we can define them as a set of things, and then we can specify a wish using these different, selecting this one and this one and this one, for example. And effectively, we have a requirement which has decomposed security to, this one and this one and this one. We're going to go into more detail about that in terms of what we do with designs, because this, whatever we select here very specifically says, find me a design to get to this one and this one and this one very specifically. So they very strongly direct your design. Here is a full-page example of a requirement written in the planning language. We'll look at a few more of these as we go along. You'll notice the first thing is not a one-liner like a user story. Here's the nearest thing we have to a user story, an ambition level. Drastically improve air quality in London to acceptable legal levels as stated in the Paris Accord. And for some people, that's the requirement, and they're all done with it. And my view is all very nice, but not specific enough, not clear enough to direct designers to come up with the design. It's not even clear exactly what we want. So what we need to do is take this user story level, or headline level, or ambition level, or management bullshit level, we call it sometimes, and define it better, primarily by defining a scale of measure. In other words, along which scale of measure can, and here's the scale of measure, can we put different interesting points like the status, the minimum level, and the future goals, and even a thing called the stretch level. And here they are stretched out a whole bunch of different points with different parameters, identification of the stakeholders, and other things such as assumptions. So you'll see right away that this is a very rich and very structured and very clearly defined language for requirements, which if you have anything better, let me know. Okay, but it certainly is something quite different from a user story. Here's another example from a case study from Ericsson of Sweden for doubling their engineering capability. There's the scale of measure. Meter is a device for a process for how we propose to measure things along that scale of measure. And the pass level is a benchmark, the record is a benchmark, the fail level is a constraint, like the tolerable level, and the goal is a target, like the wish level. But this is from a real case study. We use a process, this process that we've been through, we call it the Evo process. For evolutionary value delivery, and it includes, of course, design steps and decomposition steps, but it includes requirement steps, and it includes delivery and learning steps. But in one word, Evo is, if you like, the project management process, and here are the various steps. So this is all, of course, part of language in the competitive engineering book. Okay, so that's the review of the background and in fact the basis for the design course. And part 0, we say, what is design? A word everybody knows, but if I ask you all to write down your definition of the word design, I'll make you a bet. And the bet is no two people would write down the same definition, and most people would have very different definitions from anybody else. It means it's a very ambiguous word. In fact, maybe I've dragged you into this course on false premises. You thought design was something entirely different from what I'm going to talk about. Sorry about that. What I can do is I can tell you what I mean by the word design, the concept. And it's a design is a suggested solution. So the process of design generates suggested solutions. So there we have both design the process and design the noun. 2, a problem specified by the design requirements. In other words, this stuff. Now, a design solution suggested might turn out to not be valid. In other words, somebody might think it gives us enough security, but maybe it won't. Somebody might think we can afford to do it, but maybe we can't. And this is what the designer has to figure out. They have to figure out valid designs, in other words, designs that get us to our goals, and they have to do so within our budget. So looking at our graphical icons here, we introduced this fellow here, function, and then a value, and then the idea of a design. And here's a design that seems to the width expresses the impact or how good it is. We'll look at that more later, but it's better than our need, our goal right there. So that's a perfect design. Here's our cost constraint, our budget, and this design doesn't use more than our total cost, so that's quite acceptable. We can afford to do it, and it does the job. So that's the definition of a perfect and valid design. In other words, it delivers the levels of values we have specified that we want without exceeding any resource budgets, and that means people, time, money, space, and things like that. And it also does not exceed any other specified constraints, such as European Union, GDPR, privacy laws, and things like that. There's plenty of those. Here are some synonyms for the word design. That is the architecture, technology, the means, solutions. Management might talk about strategies, even tactics, things like that. But they're just stuff you do in order to get to the ends, the requirements, to fulfill requirements. So that's my definition of design. Here's a very simple design specification example from a training course very similar to the BCS training courses we planned to hold and have held for about 7 years, courtesy of the specialist group on quality. And so here's a design tagged using external sources. It's a solution idea. It's part of some larger concept of design. There's no summary here, but they went straight to the description. So this is the description. Here are some ambiguous terms like programming language, which we've taken the trouble to define, and algorithm, which we've taken the trouble to define. So a fairly well-designed, fairly brief example of what do I mean by a design specification. We'll see several more of those as we go along. Part one of the course, the basics for a valid design. So we start off with the idea that we have a one or more value targets, and there is some level we're trying to get to. Let's call it the goal level, the success level. And a valid design would, or valid set of designs, we might have to have 2 or more designs to get to our target, would, when implemented, bring us to at least this level, if not more. So in simple graphical terms, this particular design has an impact which exceeds what we need, therefore it is valid. If it didn't exceed it, if it left us here, we'd say, well, it's maybe partly valid, but it either has to be improved so it becomes valid, or we have to add 1 or more additional designs so we get to our goal. So that's the very basic idea of design in a picture with the design language icons we use to graphically express ideas of design. Here I made a list. Now you're going to see plenty of slides with about 10 things there, and generally speaking, they are cut and paste from the text. They would take, I could use 3 hours just going through 10 of these in detail, so I'm not going to do it. I'm going to sort of summarize the main ideas, focus on the pictures, and then anybody who wants to review this later will have this text to go into some depth. So don't worry too much about the text, but it's there to give you an instant picture of the fact that this is more complex than one simple idea, and you can review it at your leisure later or read it in the book. But here's some questions to ask about your designs. For example, if you say, I think it'll get us to more than we need, so that's good. You could ask the question, has anybody ever done that in practice? And if the answer is, well, I'm sure they have, but I can't name anybody, I can't give you any written source, then you have to suspect that maybe you're a bit over optimistic. Maybe the design isn't as good as you thought it was, and maybe it will disappoint you. So that's an example of a good critical question. The other is, you say, yes, Google got to this level. And then fine, but remember, we weren't just trying to get to this level, we're trying to get to this level usually within a deadline, as opposed to infinity, which is not a very good deadline. Let's say end of the year. Let's say, how much time did it take Google to get there? Oh, well, they used 10 years of corporate development with 1,000 people on the project. How many people you have on your project? 3. How fast are you going to do this compared to Google? I think you're looking at something that's going to take a lot more time to get there. The question is, within a year, how far will this get us? And the answer might be nowhere near the goal, in which case it's not an adequate design. You begin to see, using these first two questions, how a set of questions about a proposed design can help us analyze the design and decide whether we're kidding ourselves or not. Now, we're going to look at more of these questions in different ways as the talk progresses, but here's a reasonably good set of questions to ask about any design that anybody proposes, say at a meeting or in any conversation about the design. Another question is if the design is satisfactory, that it'll get us to more than we require, and maybe we have in fact 3 different designs, A, B, and C, and they'll all do that. So we have, in terms of impact on our values, we do have a satisfactory design, but the next question is, what will it cost? Now, it doesn't really matter whether the cost is time or money or people or any other resource. It's a very generic question here. Now, if we look at design B, here's our budget or our limit, and design B exceeds it. So design B is invalid from the point of view of the constraint known as, say, the deadline or the budget. So, and now we could use design B, but only if we extend the deadline, increase the budget, or something like that. Both design A and C are within budget. So, and C is maybe has the same effect as B, so quite satisfactory. So generally speaking, we should probably choose the design that uses the least cost. That would be the most cost-efficient, cost-effective design, or efficient design. And there's a concept here called efficient design, which means the same as most cost-effective design. And generally speaking, we would prefer designs which are cost-effective, but that's a simplification. We'll get back to the details surrounding that. There are things like, the risk of what we've estimated comes into place, not just the apparent estimated cost effectiveness. But either one of these would do, but why should we choose A when we can choose C and save a bit? Now, the other thing is we can't just choose up to the limit of our budget, because we might have 10 other values that we have to simultaneously satisfy in this project, and they are going to need some budget. So generally speaking, if we have 10 values, each value can use about 1/10 of the budget in very general terms, and anything far exceeding that, it's sort of stealing budget from the other values that need to have their own designs. So here again, here's a set of questions to ask about these costs, which will help you decide, whether you want to, what you want to do about this. But graphically, these represent the degree of cost, lowest degree of cost, middle degree of cost, compared to some given budget limitation. So, there was the first 2 things were, does it give us the values we want? Second thing was, does it fit our budgets and resources? But there's a third test of any design, and that is, does it violate any other constraints? Now, what are other constraints? Well, there are things like, there's quite a broad range of them, but there are things like laws, regulations, policies, plans, things like that. And you might have 50 different stakeholders, and you might have 50 different constraints you have to respect to make your system legal, valid, and consistent with other corporate things. Now, this means that in your requirements, somebody has to write down these constraints and say, these are the constraints. These constraints have to be fed to the designer. So designer must be in writing aware of the official constraints. They can't just design stuff and not know about the constraints, because then they're likely to come up with designs which in fact are invalid, in fact cannot be used, and we're just wasting our time. So the point I'm trying to make here is that the third major input about requirements, okay, value requirements number 1, resource requirements number 2, is there's a third class of requirements called other constraints, and there are a very wide variety of them. And I think we're not good enough at writing them down and making them official and feeding them to the designer. These are the kinds of things that don't show up in a user story. They're just sort of invisible, not written anywhere, and and people don't know about them when then making designs. But good design means you're perfectly aware and can be aware of any set of value requirements, resource requirements, and other constraint requirements that determine whether you have a valid design or not. So let's just say, for example, that these square brackets represent a constraint from the European Union, just making that up. And the design actually that we're suggesting goes outside of that, and therefore it's valid in the terms of giving us more than enough of the value target we want, but it is invalid with regard to the European Union requirement, and therefore we cannot use this design. It's illegal, you might say. Again, more detail about the constraint stuff when you're ready to get back to it and study it. But you might ask yourself the guilty conscience question. How good are we at writing down all critical constraints for our designs and making them visible to the designers, number one, and to any reviewers of design, a design review? They need to know about these too, so that we can, again, if you don't do that, you will find out sooner or later, but it may be after the European Union's given you a $6 billion fine and embarrassed you on videos, as certain people from Facebook and others have experienced. Here's a larger picture of these other constraints. So these are different types of constraints. They're defined and detailed in the competitive engineering book. Here's another link to the same book. Here's a diagram for them. And here's a list of questions we can ask about constraints. Here's some specific examples of the types of constraints we're thinking of. And I fear that too many of you should have a very guilty conscience about the rigor with which you identify, classify, and use these constraints to decide whether you have valid designs or not. So that's fine. Upgrade your processes. This is certainly not in Scrum. You'd have to plug it in. Here's some details, detailed example. I just made these up, but here's a performance constraint. Here are some resource constraints. Here's a design constraint. Here's a function constraint. Here are some condition constraints. Okay, now all this is stuff in the competitive engineering book. It's also the stuff of requirements, so it's not design. However, the constraints do determine your design and whether it's valid or not. So we have to know explicitly what they are for our project. They have to be written down. Oral culture will not do. And they have to be official, sanctioned by the powers that be, that yes, we must respect European Union laws, whether we're Brexited or not, because we otherwise cannot avail ourselves of the trade agreements with them. Part 2 out of about 8. I thought before I tell you how I believe you should evaluate a design, I thought I'd give you a set of ideas of how not to evaluate a design. In other words, what are the bad...
I'm sorry to interrupt. We had a question.
Question, yes.
Yeah,
Make it now.
You were talking about costs of a design.
Yes.
And David Mizell has asked, what about costs outside of a project? Do we take those into account?
Now, you say outside of a project, you confused me. Why should one consider costs outside of a project? There are costs that apply to a project.
Hang on. Okay, yeah, hi, Dave, go ahead, ask the question. David Mizell.
Yes, I'm listening
Yeah.
to Dave's question. Let's see.
He doesn't seem to be there, so I think it's.
Okay. Now, I'll give an answer. I'm a fanatic, as might have become apparent, for example, in discussing these things, in bringing all costs, short-term and long-term. Short-term would be capital cost of building a system. Long-term would be technical debt, for example, for maintaining the system. I'm a fanatic at bringing in all costs that are important or critical to the system. So that's the answer. And these designs, you need to design to cost. In other words, you need to design so that your design respects the cost constraints you have, which are many and long-term and short-term. So the answer is, I'm a fanatic on cost stuff, and that's perfectly clear in what I'm talking about. I'll talk about it more later in this lecture, and it's in all the books. Okay, so that should do for the moment. I'm a fanatic, yes. Okay, but costs that have no relationship to the project, I don't, if you know, in other words, outside of the project, as was stated, I don't know what that means. Okay, so we'll continue from here. Now, what I found is I found a lot of ways in which people take a position on design of something. And I find these immature and dangerous. So I thought I'd make a list of them and explain why I think they're not a good idea, and hopefully give some people a bad conscience now or later when they approve designs based on ideas like this. So the first one is that this is very popular. It's in this year. Everybody's using this design. So, you know, this the knees, bees. Generally speaking, what you need is a design that satisfies your specific value limits or targets, and your specific resource constraints, and your specific other constraints. That's the design you need. Maybe nobody in the universe is using your design, the one that fits all these criteria the best, but still, that's the design. So it's not a popularity contest. We don't choose designs because everybody is using it. They may all be using the right thing for them, but this might not be the right thing for you. So the only interesting question is, and it doesn't hurt to look at a popular design, but say, is this in fact the best one for our requirements, is the only question. Another way of thinking about things is, let's just take the area of security and say that, I don't know, artificial intelligence on big data is very effective for security, says somebody. It's all very pop. Well, maybe and maybe not, but the question is still, what is the cheapest design that delivers the quality level of security that we want? And generally speaking, that a design is effective for quality for other people doesn't mean it has any relevance to us. We can look at it, but we still have to say, is there anything better than that for getting us to this quality, together with all the other qualities, I should add, we'll get back to the multidimensional problem in a moment, within all the resources we have to respect, short-term and long-term, within all the constraints we have. In other words, general statements of this nature can at best lead you to thinking about it, but you really have to validate that it meets your requirements. Third one is the big boss, the prime minister, the CEO has said, I want this design. Now, what I found is there very frequently is a notion of what the top powers that be want. They've often been talked to by some very clever salesmen who know how to get their ear and how to bend it. And they're probably sincerely believe that this is the right strategy for coronavirus, COVID-19. But we would be very amiss as designers if we just said, we're going to use that design because the big cheese has recommended it. Our job as designers is to validate that any such suggested design is considered. I don't think you should ignore it, and is evaluated for how well it fits our values and our resources and our constraints. And if there in fact is some much better design that delivers the values within cheaper resources and satisfies the constraints better, that it's our duty as designers to politely point out to the powers that be that there are better options. And the reason you don't know about them is that maybe you didn't know about all these constraints. You know, you didn't understand that the European had laws on privacy, or the people who advised you are not advising you with respect to all your requirements. Okay, we have. And if you choose to do something else, that's your power. But we have documented that we informed you that in fact this was not the smartest decision. So if you're prepared to accept that criticism later, that you were warned and you choose something else, go ahead, you're the boss, and it's your privilege to get found out as somebody who blindly follows salesman's advice rather than the values and constraints of your corporation. Got it? Now, there may be some designs that we always used, and we've used them for many years, and they work very well, and certainly they should be considered because you have a lot of knowledge about them, and they're more trustworthy. But that doesn't mean that there isn't a much better design with new technology or creativity, or because we have different and higher values and lower cost requirements. So you can't just use something because you always used it. You have to consider what you've used, fair enough, but you have to look for something better as a designer. That's the job of a designer, is not to do what is traditional craft. The job of the designer is to find the best, most cost-effective designs they can. I'm showing a value decision table where we are numerically evaluating different designs with respect to different requirements. Now, we're going to go into considerable detail today in this, so I'm not going to go into it. This is just symbolic for a rigorous engineering method of deciding which design we should use this time. Here's another example of a design. This design is called Semantic Analyzer of Internet News. This is a tag or name of the design, but this does not define the design. The actual definition of the design is here, and it's done by some of my students on a workshop course like the BCS courses we have planned to hold in the future when we can, and the workshop course and held in the past. But it gives you an example of the specification of a design with an attempt to make an unambiguously clear specification by taking potentially ambiguous words and defining them as best we can. And if they're not defined well enough, well, we keep on defining. The ideal for a design specification is that nobody can misunderstand it, not the sub-supplier, not the designer themselves, not anybody you're presenting the design to, not anybody estimating the cost of design. Everybody should understand the design unambiguously and clearly. And until they do, you have a problem, Houston, with your design. Here's another bad idea for designs see, I just decided I'm going to put my iPhone, which keeps on making noises, on airplane mode. Now it won't do that, will it? Okay, and now you might have chosen a design, maybe it's one you've used before, and somebody says, well, it doesn't look like you'll reach your value goals, or it looks like it might be too expensive, or there's a very high risk in using it. And you say, yes, but we don't know of anything better. Okay, now that's not a good reason for using a design. You do not know of anything better. Turns out that just because you don't know about a better design doesn't mean that no better design exists. Doesn't mean that nobody in the universe knows of a better design. So I think you ought to assume humbly that there are designs you don't know about. They may have just emerged, they may be new technology. Now, we have this beautiful thing that we didn't have in my youth. It's called the internet, where you can find out about practically anything that has just emerged or is well hidden somewhere on the other side of the world. And so long story short, if you need a better design, don't use what you know. Try to find out what the universe knows for better designs. Google some key words and try to find, I've suggested a tactic here of saying what's wrong with the design I'm thinking about. And then you would think that the answers to that would give you some hints about what better things there are out there for those, to replace plastic, like with bamboo or paper or something like that. Okay, so don't let designers limit themselves to what they personally know. They ought to be as humbly assume there are 1,000 better designs than they personally have in their head or have any experiences of, but they can find out. So the job of the designer is not to know the best designs, but to know how to find the best designs. And the internet's a damn good first step, and superior outside expert designers or people who are domain experts in a special area might be other sources of finding out better designs. Very simple. It's amazing what you can find on the internet when you don't assume you know everything, and you say, let me see if anybody knows anything better. Now, of course, suppliers, hardware, software, services, will always recommend a design which just happens to be something you will pay them for sooner or later. And they will whisper this in the ears of the big boss, who will then suggest that that's obviously the way to go with this artificial intelligence, big data thing. So of course, we are inherently suspicious of anything recommended by a supplier. The wine waiter will probably almost always suggest the most expensive wine and commend you on your choice. Such is life. Okay, so assume that anything from a supplier is recommended not because it's the best thing for you to do, but because it's the best thing for you to do for them, for their narrow interest, and be critical. Now, I have a thing called a 12 Tough Questions paper, which, let's see, is that the, no, okay. We'll meet this later, which asks some questions about what the supplier recommends, like would they guarantee that it gives you the value levels at the cost levels that they're talking about? In other words, would they give you a no cure, no pay contract for that design? Now, if the answer is, we don't do that, you just have to pay the price and take your chances, but of course it will work, then you should be very, very suspicious that it won't work and maybe not use that design. But you can download the 12 Tough Questions paper from here, or we'll be looking at it later. But anything a supplier outside supplier recommends that you're going to pay them for sooner or later is inherently suspicious as maybe not the best design you can find. Now here's the designer themselves in one designer role called the architect, or the IT architect. And I don't know, I've been looking at real IT architects in not least London banks, take an example, and look at what they do and looked at their methods. And to make a long story short, I'm very unhappy with it all. And I've written about this, for example, in the value requirements book. I've written about things like TOGAF and Zachman practices for those who want to look back at it. But what I found is the architectural practices that IT people use do not take a deep look at values and costs. Some of them say you should do it, but if you try to find real examples of them ever doing like a quantified security value, you won't find it. Or please inform me if you find anybody quantifying values and costs from any architecture practice that you know about. I'd really love to know about that. I don't find it, okay? And I think you have to quantify your values, you have to quantify your costs, and you can't just wave your arms and say you should consider the values or something like that, which is what I find people do in their so-called frameworks. Of course, their excuse is, it's just a framework, we don't give all the detail. And what I'm afraid of is with Scrum and with Zachman and with TOGAF, people stick to the framework and they do not actually go deeper and plug good stuff into the framework. which is what you should be doing with a framework, but people don't. So I'm very, very suspicious of what conventionally trained and certified IT architects do at all. I don't believe they really do any form of architecture or design, and I would, almost as a challenge, tear to shreds anything they do as being ridiculous opinions about architecture, not based on any clear requirements for values and costs. They don't even ask for or read value and cost requirements numerically as a set. It's just not part of their culture. But please correct me if I'm wrong by showing me real examples of people doing it. I can't find them, and I haven't met anybody who claims it. But surely somebody out there has some common sense about this. Just because a design is the cheapest option doesn't mean it will satisfy your needs. It doesn't mean it isn't too risky. It doesn't mean it doesn't violate constraints. And it doesn't mean it really is the cheapest option. For example, is it cheapest in terms of capital cost, but what is the annual running cost or the technical debt problem? In other words, cheapest probably is pointing to a narrow notion of cost or resource, but you probably have to consider at least 5 or 6 short-term, long-term different classes of resource to understand the notion of cheapest. And people saying it's the cheapest option probably haven't done it. So you might get something that's cheap in capital cost and extremely expensive in annual cost by a factor of 10, and that wouldn't be a good idea. So cheap is good, but let's make sure it's a richer picture of cheap. In other words, money and time and people and space and other resources in the short term while you're building the system and long term while you're operating the system. Then you have a better picture of whether it's cheap or not. And the other problem is that statements about it's the cheapest, so let's do it, totally fail to consider all the other values that it contributes to. They're probably just looking at one of the values and not maybe the other 10. So that's an immature, childish approach to just say it's the cheap, it doesn't cost anything today or something like that. If we claim that this will be the fastest one to implement, well, that's an interesting claim and we need to investigate it. That other designs will take too long to implement. This claim needs to be validated. Maybe you're making some false assumptions or are in ignorance of speedy ways of implementing other designs. So just because somebody claims it will take too long to implement, I'd go into more depth and make sure that's really true. And for example, one thing I've learned, and we'll talk about it later, called design to cost, is that you can take a class of design and you can redesign it so it is, for example, 10 times cheaper, okay? And maybe somebody isn't considering that design to cost idea when they're making statements like this, because people generally don't. Good engineers do think of design to cost. IT design engineers do not, but I'll be talking about that later. So what? Okay, so we've used our first hour. We've done our first third. I hope to get through all the slides by another 2 hours. Might like to take a break. I think I'll symbolically drink a little bit of water or vodka. You'll never know. So. Now, another reason people can have for saying we need to use this design is because, well, it's compatible with some other designs we're committed to. Again, the argument needs to be looked into, but it could be that it's not really dependent on the use of other designs. That's just a lack of imagination or good design. And that what I find often is you can design or redesign things so that they are not dependent on other designs. Okay, design independence. We'll talk a little bit more about that. I have about 60 pages of how to do that in a chapter called Decomposition by Value in my value planning book. And here's a free download if you want to go into detail about designing for independence. But I'll be talking about that later here too. Okay, ready for part 3. Now, part 3, I'm going to put up what's it called? Anyway, I'm going to put up something I really don't think is a very good way of doing things, but a lot of other people do. And so I'm going to put it up there and bash it a little bit, and then I'll show you something better. Okay, so simple ways to evaluate and compare designs. So let me introduce to you an impact opinion table, or IOT. And here it is. On this axis of an impact opinion table, we have some value requirements: health, wealth, happiness, career. So those are values of, say, some person, and they are quantified someplace, hopefully, maybe not, probably not in this oversimplified case. And then this person is trying to improve their life, and this, actually, I should wave it at you. I have a book I wrote in 2018 called Life Design, which you can get from our website. If you're poor, I'll give you a free copy, just ask. But I actually plugged this method into the Life Design book, so you can use it to ruin your life with your bad design. Now, ways of getting health might be, for example, a better diet. Ways of getting wealth might be some investment strategy. Ways of getting happiness might be sharing joys with other people. Ways of enhancing your career might be to do a startup. And ways of improving your education might be some form of continuous learning. So here we have 5 strategies or designs for improving these aspects of your life. Now, the point of the table is we need to understand how good is a given diet with some detail, like let's just say vegetarianism, is going to help my health with its health needs. Okay. Let's just say this relationship between the diet has an impact on health, which is the primary reason for the diet. Now, it turns out that diet, let's just say it's extremely expensive to do the diet. All the food has to be imported from the Philippines when nobody's flying transport planes these days. Okay, that might have a negative impact on your wealth, and that itself might impact your happiness, and it might have no impact on your career, but it might educate you to the point that you can't choose diets which are impossible or too expensive. Now, these things here, these single question marks, are what I call side effect evaluations. And my main point is this, that any strategy you choose with the primary reason of impacting health, that's fine, and if it has a really good impact on your health, that's very interesting strategy. But before we accept this strategy, we have to say, what are its side effects? Now, asking about side effects is good engineering practice. Good engineers ask about side effects of their designs. And I am teaching engineering design here, in case you wondered. So the table sort of forces the issue. It says, if you know what happens with the diet for your health, but you still have a question mark here and here and here and here, then maybe this will make you healthy, but will ruin your wealth, ruin your happiness, ruin your career, and ruin your education. And the negative side effects of diet are so bad that even though it helps your health, you don't really want to do it. So now intuitively, we all have a certain quantity of this. The moment you suggest to a family friend you're thinking of this and that diet to reduce your weight or something like that, they might explain to you how expensive it is and it's going to destroy your wealth. So in other words, in ordinary conversation and experience, people will inform you about side effects, or you can investigate them yourself. What I'm suggesting is that all designs need to be evaluated with regard to their primary effect, and responsible designers will take a look at how good they are for the secondary effects. Okay, so here the double question mark in bold represents the primary effect, but responsible systematic engineering design will say we as responsible designers must look at the side effects before we make a decision. So that's the basic idea. Here, I'm also bringing out the idea of multidimensionality. That is, any design you think about has to satisfy not just one value, but whether you like it or not, most every design you have will have some side effects on practically all other values. And some of those side effects may be positive, they may be zero or nothing, but they may be negative and they may be severely negative, and they may destroy any benefit you have from the main effect there. So long story short, I want to introduce this keyword multi-dimensional thinking in design evaluation. Design evaluation has to always, at the end of the day, be multi-dimensional. And the first set of multiple dimensions are the values. And typically, any medium to large project, you have at least 10 critical values, probably a lot more, okay? But at least 10 that you have to simultaneously evaluate. And to do that, you can't just talk about it offhand with a friend. You really need to build a table to remind you to tackle each and every one of them systematically. Don't just, maybe a friend will tell you about that one, but maybe before you make your decision for the bad diet, you haven't looked into these, and these are going to ruin your whole day when you actually start trying the diet. The point of design is actually to figure out that things might go wrong before they go wrong. And it's generally speaking a lot cheaper to figure out they'll go wrong, dump a bad diet design long before things go wrong by gathering knowledge about whether it tends to go wrong or not beforehand. Okay, that's now the primitive way of doing it is try any diet you want and learn the hard way that it doesn't work. But that may waste you time, and it may ruin your health. So smart thinking says, let's consider the factors, let's research it before we make even a preliminary decision to do it. The other set of multiple dimensions, which is not on this chart, are all the various cost aspects and all the constraint aspects that we've talked about earlier. But even passing this test, in other words, does it meet our primary values well enough, number one? And number two, does it contribute to, or at least not destroy with negative side effects, all the other values? So now, there's an old saying, true wisdom is knowing what you don't know, attributed to several people, but Confucius is the oldest guy. And so I'd like to give you a true wisdom table. You start off a table all blanks or all question marks, and the question marks represent what you know that you don't know until you've put in a number or an estimation or something about how good things are. And the table forces you to know what you don't know, not just about primary effects, but about the secondary effects or the side effects, okay? So now, going one step further, let's introduce a simple language for saying what the effects are. So plus means it moves us in the right direction, and double plus means it has pretty darn good effect, and triple plus means it has awesome effects. Okay, a minus sign means it has a negative side effect, and a triple minus sign or double minus sign means even more negative side effects. Zero means it doesn't hurt us, it doesn't go one way or the other. The diet doesn't impact estimation one way or the other. And the question mark means we haven't been able to find any information about it. We don't know, and the truth could be awesomely bad. And so there's a risk here that we just don't know how diet's going to affect our career. Now, using this simple language for putting in our opinion, remember it's called an opinion table, we can do things like add up the 3 pluses and subtract the 2 minuses, and we get a number, 1 plus the question mark. We can do a similar thing here, and we get some idea using the numbers here how good it is. This with 8 beats this one by at least probably a factor of 8 to 1 in terms of a lot of good side effects and main effects and things like that. So there are methods out there. If you look for design evaluation methods on the internet, you'd find a series of methods. Quality function deployment is one I could name, and I talk about that in my value requirements book that uses similar methods to these. And it does force you to think. It does force a good discussion. It doesn't demand too much research because anybody can put a plus, plus, plus in there, whether they're lying or ignorant or in fact know what they're doing. So it's a start, gives a structure to the design thinking. However, here is a set of criticisms of why I think this is okay for informal, short-term, small projects and not okay for solving the coronavirus problem worldwide, is that things like typically these specifications are just nice sounding words with a lot of ambiguity. These are not defined with scales of measure. These are not defined with say a page of detail. Basis, the evidence for why we said plus, plus, plus is not given. Who said it is not determined. In other words, the source of the evaluation. And these evaluations are very rough and may not distinguish between 95 and 98%. What, for example, 1 plus is probably in the 0 to 10% category, and 2 pluses in the 10% to 50% category. And this could be in the 50% good to 100% category, but it doesn't distinguish between 50% and 100%. So it's kind of a rough language. Okay. So here's a systematic criticism of this type of thinking. Better than nothing, better to have a table, better to have some assertions, better to look at side effects than nothing. But I don't believe this is any serious advanced design technique for serious projects that you should use in order to enhance your career prospects. So here is more of the same criticisms of this. I think I went through them well enough. You can read them when you want, but be suspicious of this type of thing in areas like balanced scorecards, quality function deployments. There are a whole lot of techniques out there that aren't a whole lot better than these. But as one professor said to me about quality function deployment, Tom, would you admit it's better than nothing? And the answer is yes. Okay, but here's a whole lot of reasons why I wouldn't seriously use it for a serious project. Now, having said so many bad things and attacked it, I can say some good things about it, and I've already said them. Better than nothing, and here's why. And there's some conditions, even in a very serious project, maybe on the first hour of the project, whipping up a table like this might get the thinking going. And if some manager says, could you turn this into a more serious evaluation effort using some of those methods of Tom that you learned about, and you say yes, then fine. That's what I'd like you to do. Move from a primitive in the meeting, don't take it too seriously evaluation to something far more serious for saving the world from the coronavirus. So, part 4, moving into serious stuff. I'm gonna, this is, if you like, the star of the show of the whole course, main idea. I call it in the competitive engineering book an impact estimation table. We often, pardon?
Sorry to interrupt. We had a couple of questions during that.
Go ahead, questions, yeah.
And the most interesting one, I think, is about this. Can you take into account in open source projects the value of volunteers' time? Because they're not being paid, how do you cost or value that?
Sorry, I'm going to get the whole question. Take into consideration.
This is regarding open source projects, yeah? In an open source project, you're reliant on volunteers contributing their time.
Volunteer
no
time.
Money.
Yes, right. You still can count the hours they give. That's a resource. Money is not the only resource idea. That's primitive. You definitely, whether they're paid or not, you can look at the hours needed to do anything like implement or operate a system. So the answer is, when I'm talking about the resources I'm talking about counting the actual time spent, whether people are paid or not. In other words, including volunteers. Answer given? Yeah, right, definitely. I mean, if it's important to count, I count it. If it's completely immaterial to your decision making, then why bother? Okay, was there a second question you wanted to feed in now?
I think at this stage we're fine.
Okay, fine. Okay, anyway, so again, the name of this is Impact Estimation Table, or IE table. We also call it a value decision table in certain modes. And I'm going to start explaining what it is. Now, here's a basic model of the table. We're going to look at more realistic examples in a moment. Here's a list of all the different things we can do with the table. Or actually, I have a list which is more than 20, and I've only got 12 here. But basically, we can compare one design against another. We can look at a set of designs. If I do design 1 and design 2, what do I get? If I do design 1 and 2 and 3, what do I get? Okay. We can prioritize the delivery of designs. Which of these 3 designs should I do in the first sprint to give me the most value for money? You get the idea. But the point is, we can use the table to evaluate designs for a variety of purposes, like selection and prioritization and deletion, get rid of a design which costs too much and gets too little, and things like that. But here's a full list of all the things we can do. By the way, here's a key word. This gives us a device for modeling a complex system. And we can actually use hierarchies of these tables to model the most complex systems, such as World Health Organization solving the coronavirus problem and things like that. So you can model very complex systems. It's actually been used to model the Brexit at UK government departments, for example. It also summarizes a lot of complexity on a single slide or a single page, is in fact what they found out in using it for Brexit. Anyway, here's a thorough list of all the nice things you can do with it. For the moment, let's just say we're going to use it to evaluate how good are our designs and make choices. Now, here's the structure. So, and here's a more formal list of the structure, but let me just take it piece by piece. Here in the upper left-hand corner, we have the value requirements or value objectives. There could be 10 of these or 100 of these or 1 of these, and they're all quantified and they're all very well defined. So this is our ends, what we want to achieve. Second section here is resources. In other words, what will the design cost in terms of volunteer hours? What will it cost in terms of capital expenditure? What will it cost in terms of technical debt, etc.? So here's where we list all the critical resources that we can't afford to run out of, we need to manage. As many as we like, in practice, between 1 at the very least, and probably 6 for moderate projects, and maybe 10 for really large global projects would be the number of resources there. And in practice, in any one table, I wouldn't have more than about 10 objectives before I started decomposing the table to subtables, just to keep an overview there. Okay, now on this axis, we have each design idea, whether it be a big architectural idea or a little design idea, doesn't matter, but we identify it. And this would use the tag of the design, and then the tag would lead us to all the detail about the design. Same thing here, we often just have tags of these things, and the tag leads us to all the detail. Here in the right-hand side, if I have an impact here and here and here, and I'm going to use all these 3 designs, I can add up the cumulative impact and get some idea of how far along will I get if and when I have implemented all 3 designs. Okay, I call that the sum of the impacts on my objective. And I can say, do I have enough design to get to my goal? Is the very first simple question. Or does the totality of these, does it not even get me to my tolerable level, my worst acceptable case? Then I need more design. We do the same thing here. Whatever the resource, we've got a way of adding up resources. So we can say, in simple terms, have I blown my budget? Or have I only used a small fraction of it and I've got lots more money and time and volunteer hours and things like that, okay? So this is for getting an overview of a set of designs. Down here, we have what I call the benefits to costs or return on investment or profitability or cost effectiveness or efficiency of designs. So what we do is we take all the impacts, which is all the good stuff, and all the resources, which is, we don't really want to use them if we could have zero resources, and we derive a benefit to cost ratio. In other words, we can take a look at the cost effectiveness of this design versus the cost effectiveness of this design versus the cost effectiveness of this design, and we can choose the most cost effective design if we wish, or choose to do the design which is most cost effective first if we wish, make other decisions like that. Okay, so now you have roughly an idea. We're going to look at more detailed examples of tables with sort of real numbers and real definitions in them, but I'm just giving you the structure. By the way, I've invented this table. I've used it for about 50 years all over the world, but it's a main idea for this whole value design. How do we manage the design? And the answer is we put it in tables like this and get to understand how it is for values, for costs, and compared to all other designs. Let's see, structure, there we go. The table ties many of our processes together. So here is the requirements process. Here is the design process. We can use the table to see the need for decomposition or to, in fact, expose a decomposition to ourselves, okay? We don't use it directly for development, but we do choose what to develop, and we do choose when to deliver, like how to prioritize a certain design for delivery. When we measure what happens to the values and costs, we plug it back into the table as feedback. We'll show examples of that. And then by comparing the feedback, what really happened with the design, with our expectations or estimates for the design, we learn whether it met our expectations or not, and change design or change expectations. And we continue the cycle until all formal values are met, hopefully within our resources and conditions, and then we exit the process. We've delivered the system. Okay, but long story short, this table helps us and interfaces with a lot of different processes. Now, here's a real example from people who've actually held nice lectures for the quality specialist group of the British Computer Society. Here is a link to their study. They're now, last time I heard of them, they're at some Irish university doing further research. But they did what they called one of the few successful projects in the national health system. This is actually a system for getting pharmaceuticals from the hospital pharmaceutical store to the patient without killing the patient with too much of a bad pill. And but the beauty of this was it was simple, but here they are quantifying different values, and they're quantifying time as a resource. They have some different designs or strategies, and they're putting in some evaluations. There are two numbers here. One is what we call the real number, and the other is the percentage of what we need to get to, the relative number. We'll be looking more at that later. And here we're adding up the numbers. 200% means this one does the trick, gets me to my level of 10 minutes. This one also does the trick, so I could use this design or this design. If I use both of them, I might get beat the 10 minutes by a factor of 2 or something like that. I have over design, or as Kiesinger called it with regard to the nuclear arsenal, overkill. Okay. In this case, we have a budget for time to learn and 1 hour. And if we add these designs up, here we actually have no knowledge, so danger areas. Anyway, long story short, it's a real example of a case study where we have the results of the system they developed using language in the hospital, reported to British Computer Society. So, simple, real example. This could be done on any kind of a table in Word or spreadsheet, for example, which is probably what they used. Here's another example. This is one of my favorite clients. It happens to be a Norwegian organization which builds Gallup survey software for the entire world. I think they export to, goes to all countries in the world. And they used our methods to very, very good effect. And here, here we're looking at their table as they used it when they learned it from us. And I'm not going to go through all the details. There is a case study right here. But the fun thing is they've got the requirements baked into the table with the pass level, the tolerable level, and the goal level. This is a small team of 4 people focusing on these 4 usability type of requirements, which are all quantified. They're at sprint 9. They're going to implement marketing information recoding design, which was estimated to take 4 days and deliver a 20-minute saving on the time needed to generate a report. They needed to, the goal was to move from 65 minutes to generate a marketing report down to 25 minutes. So that means they needed to save 40 minutes. And this alone was estimated to save 20 minutes. It was also estimated to use about 4 days of work for the team. Now they did it, they implemented this in a sprint, and then they measured, actually Microsoft Usability Labs did the measuring for them, that in fact they saved 38 minutes, which is pretty near to the 40 minutes they need to save. And this got them 95% of what they needed, which is 40 minutes. See, this 20 minutes is only 50% or half of what they needed. So the design was twice as good in practice, at least at that increment before they scaled up, and scaling up might not show the same performance. But they got some real measurement that this was at least as good as they thought, and with luck would hold. These signals here are traffic light signals, where red means we have a problem, Houston. We haven't even reached the tolerable level. We're in failure mode. Green means we've reached the tolerable level, but we haven't reached our goal, so we're not successful. And green means we've reached the goal, we are successful. So these are priority signals that signal things that you should worry about on the next step. Say step 10 would be the red ones first, and if no red ones, then the yellow ones. And if everything is green, problem solved. So here's this table was whipped up by Trond Johansen, who wrote the case study, and he led the change effort to our methods in this organization. And he whipped it up on a spreadsheet one evening. 2 years later, he did a much more advanced tool using spreadsheets, which he made available to us. But so this is a simple example of both the requirements and the impact estimation table on a simple spreadsheet being actually used quite quickly to manage their projects. Here's another view from them. What they did was they had a total in the first quarter year of about 25 values. Here are the names of them. Here are the goal levels. We don't see the scales. They're invisible here, but we can find them when we want them. And this is actually a progress report to, if you like, the project manager. the burn down chart, except it's really a burn up towards value chart, where we can see, and each one of these is managed by the 16 developers and testers, about 4 people here, about 4 people here, about 4 people here, about 4 people here, who've been given 12 weekly increments, 12 sprints, to deliver the goal levels by the end of the quarter of a year when they release the software. And I'll make a long story short, in using this method, they invariably were able to attack and deliver 25 simultaneous quality or value targets every time they tried. And one of the reasons is they're using what I call dynamic design to cost. That is, they're using these numbers to prioritize their work on the next increment. If the number is 100 or more, no more work is necessary, drop it. If the number is severely below that, like 66 or something like that, or 13, then this is, red. This is what we need to work on our next increments. And by selecting to work on the weakest links in the chain, as viewed step by step or sprint by sprint in measurement, they managed to get just about everything to green or better by the time they did it. If you realize this is week 9 of 12 weeks, in other words, they're 75% through their budget for time. And if you compute the average of these numbers, which you'll find is far greater than 75%, you'll find that they are, generally speaking, ahead of the curve. And by working on the weak ones in the remaining weeks, they're very much more likely to simultaneously achieve all goals they've been given, which they in fact do. And they were so good at doing this that they actually wiped out their international competition from the market and bought them up. Is part of the story there, which is why we're proud of them using these methods. One of the competitors they wiped out was called Pulse Train, 100 people in Britain, which had not used these methods and therefore got wiped out of the market by a Norwegian Viking competitor, which did use these methods secretly. And all the customers decided they wanted to buy the Viking product, not the British product, because the qualities were so much better and so much faster. Nice little story there. Britain is hereby warned. After about 2 years, Trond Johansen, my hero who implemented these ideas at the client, said, I've got some news for you. Remember, we had a problem with technical debt. It was horrible. We'd spent 8 years hacking together the software and it was spaghetti, and we couldn't change it fast enough to respond to the market needs. And it was very threatening because younger competitors could do that. And the initial suggestion was use 1 day a week, every Friday, to refactor the code and reduce the technical debt. And long story short, that didn't work. Maybe because Norwegians have a strange tradition on Friday of doing home office at their summer cabin on Friday and beating the traffic, so no work actually gets done. So he said, what we did was we used the same method we were using for all the other things, except we defined technical debt as this set of things: speed, maintainability, testing, etc., resource usage, synchronization. And we quantified all these goals. And we defined technical debt as this set of things. We set goals, and then we used what we call a green week. That is, every 4th week in the month, we focus the whole team on delivering these goals. And in delivering these goals, they reduce the technical debt and make our product very much easier to maintain. And we're not in any way limited to something as narrow as refactoring of the code. We do anything and everything, including a lot of test automation, which actually improves the technical debt situation at the client. So there's a paper on that, the Green Week technical debt. This is, historic first in using our engineering methods and very explicitly the impact estimation table to manage technical debt. A lot more mature than just letting a coder refactor the code. Now, finally, here is a more detailed impact estimation table, and a lot of numbers, a lot of structure here. And if it's the first time you see it, you might feel a little bit overwhelmed. I'll solve that problem later. But this is, if you like, a lot of the detail. For example, we've brought in the detail of the different requirements. Here's the scale of measure. We can bring in more if we want or leave it out. This is actually, these numbers here are both the real number for how good is it on the scale of measure and the relative number, what percentage of the goal we want to get to are we getting to. This bar chart is actually a simplification. The bar chart says that symbology is estimated to get us to 68% of our goal for usability, 68% of the way from 0 to 95% of the scale of measure. So this bar chart says we have a negative side effect of minus 30%. This says we have the copyright review gets us 95% of the way to the copyright law compliance goal of 100%, etc. So their simplification is actually in these bar chart numbers. But there's a lot of other stuff here we'll get into in more detail about the credibility and the uncertainty and the risk. It's all hidden in this table. Here we've actually summed up these percentage numbers, and we get this a way of looking at the sum of values. In other words, the total overall contribution of this design is 310 by adding up all the percentages. And by contrast, symbology as a design idea is only 42%, about half as good overall for the 4 different values. Okay, we'll look at this more later, but here's a rough, quick look at the detailed impact estimation table. Now here's a look at the table where we take one of these cells, which is the, here's a design, and this is actually from a British Computer Society, as many of them are, example. So these are students of British Computer Society. And T-kiosk is then a strategy, and we're hoping to improve user productivity, number of minutes for a user to do something from 15 minutes down to 5 minutes. So we need a 10-minute improvement. And we estimate we're going to get 8 minutes plus or minus 3, but that's about 70% of what we need. Now, the question is, how did these wonderful numbers get here? You remember I criticized the impact opinion table because I couldn't see how they got the plus, 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 or who did it. But we do that here. Here's the number of minutes we think we'd save. And here, by the way, is where we'd feed in what really happens when we implement this, but this is design stage, so there's nothing happening here. And then we ask a simple question, which is one of the 12 tough questions I mentioned earlier. You say you'll save 7 minutes if we use T-kiosk. Now, how do you know that? What is your evidence? Okay, and here's somebody's written down some evidence here. This is just student work, but trying to learn the concept of writing down evidence. We have used T-kiosks, and several competitors have, which save about 7 minutes for users. Well, that sounds good. It's really been done, and others have done it, and it really saves about 7 minutes. And what is your source for this? And here is a link to TripAdvisor reviews, which apparently show some things. So in other words, if this is a lie, you should be able to go to review it or quality control it by going to the source and finding out whether this is true or not. So we ask 2 questions. What is your evidence for your number? And what is your source? So we can check or review this. Now, the evidence and source are strong enough that we actually assign a credibility to it on a scale of 0 to 1, where 1 is perfect credibility. I mean, it's going to happen and you can bet your life on it. And 0 is this is just random noise, and it's a random number, and there's no connection between reality and the estimation. That would be 0. But with in-house measurements, etc., correlating to external sources, we get 0.8. In other words, we get high credibility. That, by the way, is this little number here. In other words, high credibility, pretty high credibility, pretty high credibility, no credibility whatsoever. So what we're doing is we're analyzing risk, that our estimates of how good the design is any good or as good as we say. So we can distinguish between total bullshit estimates, 0 credibility, I mean, it's very nice, 70 and 67, what's the difference? Well, the difference is this is a very high credibility estimate based on reality, and this is almost like a random number worth nothing, so you're kind of wasting your time. Another thing we do is we say, well, wait a minute, 7 minutes, but could it be 8 minutes? Could it be 6 minutes saving? That's the minus. And somebody says, well, it could be 7. We say, what's the range? And the answer is plus minus 3. So what's the worst case? And the worst case is we don't save 7 minutes. We save 7 minutes and take away 3, and we only save 4 minutes. So the worst case is we only save 4 minutes. And you'll notice the 8 plus or minus 3. I'm not quite sure why that ended up being a 7, but maybe it's a bug in the tool at this point, who knows. But 8 minutes plus or minus 3. In other words, in this case, 5 is the lowest number of minutes, and 11 is the greatest saving we could get here for this. So this is this plus or minus uncertainty, we call it, is another way of looking at risk. In other words, what is the risk that it isn't as good, or it isn't as good for our case as is generally the case to many other people? And we force the issue by saying, give us a number, but give us the range. Okay, so that's what we call uncertainty, evidence, source, estimates. So we're managing the risks of designs not being as good as some people hope they are. We're forcing them to think about what we really want here is not to have good evidence, but when people have bad evidence, they don't know what they're doing. We want them to go back and find a better design with higher credibility, or find out more information about the design before they waste executive time by presenting ideas which aren't worth shit. Got it? We want to force people to be good engineers and do good engineering with their design. In other words, design engineering. Here's another design specification. Again, here's just the tag or label of the design, the name of it. It's part of a larger architecture called the content review system. We're keeping track of that. And here is a summary. Down here is description, which may go on many pages, but I haven't made that visible. But here's just a summary of the design. You notice that these are a lot bigger than the designs often specified in the middle of a user story, which is often, you know, like it just says bullshit buster on YouTube channel. In other words, what we call just the name of it is all the information you get about design sometimes. Here we're saying, no, you write down a little bit more detail so nobody can misunderstand. And if the term presenter is not clear, define it, man or woman speaking in the episode. If newspaper is not defined, write down, well, these are Polish newspapers, so this must be one of the Polish courses. Okay, Poles are very good planners and they deeply understand these methods. I would say better than the British, but show me better British examples. Okay, now, for purposes of presentation, things like this are a little bit too messy to show to an executive that isn't used to it and doesn't know it in depth. If an executive said, give me the detail, I want the detail, or drill down, then we can show them this and we can start showing them little details like this. But for initial, let's call it executive presentation, you want something as simple as this. Forget all that detail. It's there, it's in the database, but here are intelligible to any executive is improving the housing type from this number to this number and the crime rate from this number to this number. And we've even wiped out the scales so we don't give people too much, but somebody wants to know what scale of measure you're thinking about, we can easily click on these and get it right away. But here are the evaluations. So this simply means modular construction will get us halfway towards our housing type goal. London living rent, and this was obviously done by the BCS courses, will get us halfway to this goal. And the more deterrence will have a negative effect of minus 300% on the crime rate. Oh dear. But it will have a 250%, in other words, 2.5 times more than we need on the type of tenancy goal. Well, wow, maybe that makes up for that almost. And these will have no effect whatsoever on the average cost of a home, so maybe we need some design there. Here we have a situation where modular construction has an unknown effect on rental charges and has two small negative effects from the other designs, and we don't have anything good there. So we don't have any design for impacting the rental charges. And okay. So, but take this as a presentation version of the impact estimation tables. Okay. Just for fun, we're about halfway in the talk, and we're at slide 64. We have a little over 100 slides, so we're on track. And I'm going to take a drink of my vodka or water. Best of luck to Manchester United whenever start playing football again. May the Norwegian Viking captain win, Mr. Solskjaer, and the team. Be nice to have some Norwegian players on Manchester United team too. Okay, but so I'm giving you this as an example of the fact that you can simplify a table so any manager can and should understand all of these. These are management level critical goals. They should understand roughly, at least from the tag, what these are or get the detail. And they should understand, if I do this, it gets me halfway to my goal. So this is very intelligible at a non-specialist, non-expert level. Let's call it the management level. Okay. Now, down at the bottom of the table, just below all the values which are up here, we can have any interesting number of budgets for resources. And here are some: capital cost, calendar days, full-time equivalents, and maintenance costs, okay? And each one of them has a budget level, which is sort of the most of this resource we can afford to use, or which is officially allocated. And generally speaking, before you start doing anything, the status is we start at 0, but maybe not. This is something, again, done almost certainly by students at British Computer Society courses. And now here are some estimates. This is the real money. Here's an unknown real money, plus or minus 1, real money, plus or minus a whole lot. Here we're adding up the numbers. We get 21%, meaning we're at 21% of the budget for 1, 2, 3, 4, 5. And it probably is, I'm guessing it's this set of things, which is more than the 3 I'm showing you. Now, notice that this turned red here, and it says 208. And this didn't turn red, it's 152. The reason is we've set as a default the safety factor level at 200, or factor 2. It's quite normal in design engineering to have a safety factor of about 2, and I found that managers quite like that safety factor for both values and costs, but you can have a higher safety factor. When I'm tuning in my car to the number of cars behind I should be trailing it automatically, I have a choice between 1 car behind and 7. And I always turn it to 7 cars behind, because I want 7 cars distance between me and the next car when disaster happens. I'm a very risk adverse guy. So you can choose your own safety factor, but safety factor 2 is chosen. So what this means is it's, you know, it's okay. And what this means is you've exceeded your safety factor. You're using slightly more than the most you could overrun your budget. And we need to maybe find cheaper designs or be prepared to accept the fact that it's going to cost about that. Here at 5%, meaning you're using only a very small fraction of your 100% of your budget. And your maintenance cost is not threatened yet. So long story short, we can take any variety of money, time, people, future maintenance costs we like, and set up a budget. And then for each and every design, the designer should estimate what their design is going to cost in these areas. If a designer cannot estimate, here's an example of that, an example of that, it means we have an unknown cost with a critical budget. And if the truth is it costs a lot more than you can tolerate, we have a failed design, a design which is unacceptably expensive in some dimension. And we have a known unknown, as Confucius would put it. And maybe we cannot proceed with selecting this design until we've done some more estimation. The question mark just says, nobody's tried, maybe nobody can do it. But bad shit could happen if we can't simply progress with this design. Okay, these other designs don't seem to have that problem. And let's just take a look at their credibility. 0.5, pretty good credibility, 0.5. Here's a lot of zeros, 0.5. Zeros mean we really don't know what we're talking about. It's actually a quick student exercise on a BCS course, so nobody's had time to research the capital costs for this. And but we're saying, okay, that's fine, but they've made a wild guesstimate of 45 plus or minus 30, but it's not backed up by anything substantial. So if management wants to be certain they're not going to blow their budgets, they need to give the designer more time to find out what this costs and get a higher level of credibility before we proceed using it. Okay. Here are a longer list of different kinds of costs we can put in this section of the table if we want to manage development and operational costs. Okay. Here's yet another level of simplification. This is actually the table, except we've taken the sum of all the values and got one bar chart thing here. This is also the sum of the plus minus, so this is the worst case. This is the best case of the values. And we've then taken the costs, these are the costs, and we put them in again with the best and worst case. This little thing means nobody's really evaluated the variation there very much. A big thing here means they have evaluated the plus minus, okay? And these are the different design options. And so which one give both best value for money? And this is all the values for all the maybe 5 different types of costs. So you'd think that generally speaking, now let's just say cost doesn't matter. We're rich, we have infinite budgets, infinite time, no pressure on resources. Then I'd choose database design because it gives, even in the worst case, very, very good value. This one might better it in the optimistic case that it delivers more here. But the moment somebody says costs do matter, we do have budgets, we do have deadlines, and we do have a limit to the volunteer labor, which is qualified medically for treating viruses, then we have to bring this into consideration. So it's the value to cost ratio which counts. Now, which one of these has the highest value to cost ratio? I'm guessing this one, symbology, just looking at it, but this is a spreadsheet, and we can simply say, reorganize the spreadsheet to show us the highest value to cost or the highest value to cost with regard to the worst case or something like that. We'll show you more of that later. But this gives us a simplified presentation that these are the architectural options we're looking at, and this is how much overall good this one called database design does. Don't worry your management brain with all the technology here, and unfortunately it's a fairly costly option, like 5 times more than this one, which is almost as good. So that's why we're thinking of doing this one first and seeing what happens, what it really costs and what it really gives. Here's an even more advanced option of the same things. Again, this is turning the table information into bar charts. And so what we're doing here is, you can read the list here, but this is the performance to resource ratio. So we're integrating this over this. In other words, the efficiency of the design, the cost effectiveness, the profitability, if you like, overall. And but then we're saying, look, here's the planned level, but if you ask me about credibility, here's another level. If you ask me about the worst case, here's another level. And if you ask me about what really happened when we measured, so here are some estimates, and here's what really happened. This is a way of viewing. In this case, we've already implemented these. Therefore, we have some feedback and measurement, as Confirmit did, what really happened with the sprint delivery. Here we see we are consistently underestimating how good the design really is at the end of the famous day. Okay. What we do with this, I don't know, we could say, maybe we are systematically underestimating, maybe we should up our estimates a little bit more or something like that. Or maybe we're systematically underestimating certain classes of things and not really underestimating very much other classes of things. Why is that? Don't we have enough expertise? Anyway, a way of looking at designs. Okay, deep breath. Now, part 5, I'm going to look at a way of starting projects using these methods. I have a thing which I usually call a startup week for an Agile project. It's similar in concept to a design sprint week, which I will criticize in a moment, except it's much more engineering and much more systematic and stuff like that. Just for fun, I've renamed the method the POW method, which the acronym stands for Planning Optimization Week. POW. I thought that was at least fun. And what we do in the first week, I've been practicing this for at least 3 decades in very large corporations like Hewlett-Packard and Boeing and Ericsson, to mention a few. So we got lots of practice here. And banks like JP Morgan, for example. Anyway, on the first day of the first week, we do what we taught in the previous course. We quantify the top 10 critical values. Refer back to that course or the value requirements book. Then on the second, and I'm going to show examples of all of this. On the second day of the week, we get into design mode. And basically, we try to pull out let's say the architecture, the top 10 technical organizational things we have to do that we think will help us reach the values. So at the end of the second day, we brainstormed a list of 10 architectures which we believe in. And the first day, we've brainstormed and quantified the top 10 critical values we have to satisfy. The third day, let's call it Wednesday, we build one of these tables and take a look at, try to generate some numbers for how good we think these designs are or these architectures are for reaching the values. And if we seem to have pretty good numbers and reasonable possibility that the architecture designs will reach the values, we feel comfortable and we move on to step 4 or Thursday. And we start getting very agile because we start asking a very dramatic question. What can we do as some subset of this architecture or design so that next week, or at least next sprint, in a very, very large long-term project, sprint could be a month, not a week. What could we do next sprint to deliver some small component of our architecture so that at least one of our values went measurably forward? We could confirm that some part of the architecture delivers some of the values, maybe to a real system, typically the old existing system, okay? And it says what we're doing is we're validating or proving that the architecture at least partially works as expected. This, by the way, is exactly what Confirmit did. They did this week, and I showed them in the 9th week actually delivering these values. But Thursday just simply says, let's stop pontificating in the first week. We'll allow pontification for a week and start delivering real measurable value in the second week and third week and fourth week until all value is delivered. Exactly what Confirmit does. And then, so we've got an overall plan, which includes the idea of what are we going to do in practice on the first sprint. And the 5th day, we might go to the powers that be, the director, and say, this is our overview, this is our plan. Do you approve us using this agile as it should be, as I like to call it, value agile, which will be the subject of our fourth SPA course about 3 weeks from now. Do you approve us doing this and proving next week and every week that we really get some of the critical values we want? On this 5th day, what we found is that management always says yes, for the simple reason that they can't resist seeing if it works and if it really gives measurable critical values that they can brag about to their boss when their boss says, how's it going with your project? So it's a given. This is 3 to 4 decades of experience of using the method that says it's irresistible to a boss who wants to remain in power and get more powerful to say yes. But we do ask permission. So here again are the days. I just went through what we do. Here's the purpose of each day, like why are we quantifying the values? We want to clarify our critical values. Why do we pick these powerful designs and strategies? Because we want to decide on the main architecture. Why do we do the impact table on the 3rd day? Well, we want to get a look at the cost effectiveness and make sure it's not insane. Why do we decompose strategies and at least find the first thing we can do next week? And what we're trying to do is select a very high value to cost sprint so we can get going next week and do something real. And why do we present to management? And so that, well, we can blame them if it doesn't work, okay? Here is, by the way, this process starts off and supports the cycle I've talked about earlier, but it's the first round of the cycle at the top level. And then every sprint thereafter, we actually continue going through these cycles until we learn that all values have been delivered and we're done. And we can ask the stakeholders what they want in addition if they'll give us more budget, more time, and more power. But so this puts us on the path of learning by doing. And one thing we're learning in this context is we're learning whether the architecture and design really works. We're learning what it really costs, and we're learning it early on the 2nd week of a project, no matter how large the project is. We've done projects that are 8-year projects this way. At US Department of Defense, for example. I'll show you an example of that later. And this method scales up to very large, long-term, complex projects. But it also works on smaller projects. But if the project only lasts 1 day, I don't think I'd bother with all of this. Now, the big trick for making this work is, in simple terms, figuring out a smart thing to do next week, which delivers very high value to cost. Now, we're not just normally picking one little thing to do out of 100 or 50 steps. We're actually doing something I call decomposition, decomposing. Now, before I go on to talking about decomposition, I'd like to make a point. These methods work with hardware and software and organizations. They're not pure software. They're not pure programming. Many of the IT methods people use are very, very focused on coding and programming and very little else. They really aren't systems engineering. But all software operates together with databases and hardware and people and organizations and markets. So I think IT people really need to admit that they have to be systems engineers and tackle the whole system. One example which really excited me, I read a book on the biography of Elon Musk, and he made a point of his method. He does something no other car manufacturer seems to do. He delivers every increment or every sprint 20 improvements. 10 of them are software improvements which can be loaded into previously delivered cars if they have the prerequisite hardware. And 10 of them are improvements to the production of cars that week, like you might put in a new Nvidia computer 40 times more powerful than the old one for hopefully self-driving of the cars. He did that one Monday suddenly. In other words, he's doing quite radical hardware upgrades to the actual production. He doesn't wait for year end to change the whole model. He 52 times a year actually changes the design of the hardware, and maybe something like 10 to 15 times a year changes the software, which is, I downloaded yesterday my latest software to my Tesla S, for example, and it changed the car in interesting ways. In other words, what he's doing, he is doing Agile as it should be. He is delivering hardware and software value to a car approximately every week. And if he can do that on cars when nobody in Detroit dares do anything similar to it, that shows you what you can do on almost anything of that complexity and worse. So if you start saying, but we can't decompose this, I'd say that's what General Motors and Volkswagen would say, but geniuses like Elon Musk say, I can decompose it and I can make a very interesting, extremely safe car. And take a look at the now in profit after a long period of startup, and now with a very much higher stock evaluation than ever before, even in Corona times, interestingly enough. So, model to look at. Now, I have concluded in my years of being a consultant to businesses all around the world that most of them hand me their thinking on their digitalization project, their whole new hardware, software for making everything better by throwing out all that awful old hardware and software and getting some new ones, which the supplier is very happy to propose. But what I've found is that even the most radical digital transformation should probably not be done by buying a lot of kit, hardware and software, and reprogramming everything from scratch in a new programming language, as so many government organizations do. Okay, what I found is what people really want is not new hardware and software. Now, the supplier would like it. The technical people would love to play with the new hardware and software. So there's a military-industrial conspiracy to get management to buy new kit. But what management really wants is improved values for the organization as soon as possible. And they want a value stream of getting better and better. And they don't honestly care when new kit is swapped in, okay? And they would much rather than having new kit and a failed project, and our project failure rates are abysmally bad, look it up, IT project failure rates, Google it. What we need is projects that do not fail, that they deliver enhanced value compared to the existing system, however old and decrepit, week by week, sprint by sprint, until management has the set of values they want. Now, at the end of 50 sprints, the end of maybe 4 years, maybe they'll have a lot of new kit, new hardware and software, which has been almost invisibly swapped as you went along. But we keep our focus on delivering value step by step, and swapping hardware and software only when necessary and only when we can do it without disturbing or failing the real system. Okay, and that's the way I've always built systems and always advised my clients, and usually talk them into it, is building value step by steps. So now here's an example of doing that. This is a US Army or Department of Defense for SINSCOM. It's actually a system for personnel in the Army. It was an 8-year-old system which had totally failed in the Gulf War, and the commanding general, Schwarzkopf, complained, and I got the job of advising them after 8 years of building the system how to get back on track. What they did is a whole case study, which you can find down here in detail, but they did the 1-week startup, which is why I'm showing you this slide. And on the first day, they took their values, which are listed here, and they numerically said how much better they wanted each one to be. On Tuesday, they named all these different things like business process reengineering and technology investment as high-level architectures. On Wednesday, they built this table with the value estimates and the cost estimates. And they found out that this particular thing, business process reengineering, had a 30-to-1 return on investment, as opposed to this one, which is only half of that. So they could begin to prioritize where they should start. They also ended up using this to decompose the problem. Here's a decomposition into values. Here's a decomposition into strategies. And this big fat number here, 200, turned out to be the hotspot. And we found a subset of business process reengineering, which could deliver slightly improved availability next week, we thought, but in fact, it was so simple, they actually got it same week as we did the overall planning. And the actual thing they found was that if they prioritized by rank of officer asking questions by moving them to the head of the queue, they got much higher availability of the system. Oh, and shouldn't get into the detail of that. But they actually found something they could do next week, which was so simple they did it this week, that they could start delivering results. Okay. Anyway, what they're doing is they're not rebuilding a whole new system for 8 years with new hardware and new software. They're getting dramatic improvements in these qualities, because the next war won't start in 8 years. The next war might start next week. And we need to be as prepared with increased values to the systems as we can get, as fast as we can get, with priorities set here by selecting this set of things and this degree of things and things like that. So,
Tom, can I just stop you for a moment?
Yes, stop me.
Those are very impressive stories, you know, and success breeds success. There are situations in which you don't necessarily, you haven't necessarily got the circumstances under which you can identify a very, very quick saving like that. So Jerry Tavares has asked, you know, if you need to develop a system architecture before you can deliver any part of the system, you must have come across situations like that. How do you deal with it?
Yeah. Well, first, what I'm very clearly suggesting is I do not believe you should develop an architecture as IT architects do with their TOGAF and Zachman and things like that. They do it time and again in total ignorance of the values you have to deliver. You cannot find a numeric specification of the critical values and of the costs. They just start developing the architecture on a whim, and that's stupid. Okay, what I'm suggesting is on the first day of any large project, you should quantify, as US Department of Defense has succeeded in doing on the first day of the project. And then you find this is, in fact, the top level architecture we're looking at here, right? These are the big architectural ideas which can be detailed, but they're not detailed here. So that on the day 2 of the project, they are developing a high level architecture, but they're not using weeks and months to do it. They're using 1 day to identify the new sexy architectural things they ought to be dealing with. And then they try to give themselves a warm, comfortable feeling about whether these architectures will have an interesting impact on their values. And if the answer is yes, they say, fine, Thursday, pick some subset of this. Here's not big fat number saying that there's some subset of business process reengineering architecture, and we found them. We found several, which we can deliver next week, which will deliver something improving this. And we just go ahead and do it, thus validating this architecture to some degree, thus delivering a real result to the real Department of Defense in case the war starts in a week. And the crazy, stupid IT architecture I see, the nation would be defeated and go down in flames against the enemy because they're so busy developing their architecture for months that isn't going to do anything anyway. Oh, if I sound like an angry young man, I am. Did I answer, sort of?
Very much so. Thank you.
In other words, I do not I believe big upfront architecture is as stupid as the waterfall model is. I believe we need to do this agile. I'm talking about a very advanced agile method right now, right here. Next week, start delivering real results, not code, not a burn down chart for some use cases, but deliver measurable value to stakeholders. I'm suggesting serious agile, and the architecture notion that I heard here tastes to me very much like Big Bang waterfall, which should be discredited by now. Shall I continue? Not hearing anything. Imo, you're there, right? I'm not hearing anything.
Yeah, sorry, I had my microphone muted. Yeah, please do.
Oh.
Don't wait for me.
Oh, okay. Right. So I'm very explicit. My experience for decades on all kinds of systems all over the world, large and small, of all nature, is that almost never should you start building a new system from scratch. And by the way, let's call that the waterfall model. Okay, almost always you should do agile, delivering a stream of value from something like the second week or second month of a project, no matter how large or complex that project is. And we gain several things there. One is you start actually improving the real system in case the war starts or the coronavirus starts suddenly next week. Okay, and number two, you force the architects and designers to confront the reality of how good their architecture is for doing the only thing that design should do: deliver value at a reasonable and profitable cost. Okay, in other words, what you're doing is you're putting the architects and designers in the loop. I'll be more explicit about this later in the course, but so that they have to confront reality of how much security or user friendliness you really get from that flimsy design they suggested, the vague design that really won't work. You force them to confront their maker, their of bad design as early as possible. And if designers can't design stuff that delivers value, you need to either remove or improve your designers, because they have only one role in life, and that is delivering value for money as soon as possible. And I call this agile as it should be. Okay. Anyway, my experience is that the idea of building a new system from scratch is the wet dream of the suppliers and the technologists, but it in fact is not interesting for the managers and stakeholders. They want results as fast as possible. Ask them. The greedy conspiracy, which wants to talk everybody into replacing all their kit at great expense for several years with failed large-scale national health type projects. We have failed national DHSS projects in Norway, which are 6 years, 6 billion total failure, fire the minister type of IT projects, and we know that Britain has the same thing. The problem with all those projects is the ministers didn't demand results stream quantified from the second month of the project and on until it was all delivered. And we need to train our politicians and ministers to manage these projects a lot better. And I'm giving a recipe for that management when somebody wakes up to it. It's not easy to change culture like this, but I'm giving you my idea of a recipe for it. Now, I mentioned earlier the 12 tough questions for asking questions about suggested designs. Here they are. And there was a paper on that suggested earlier. And here is some of the reasons why this greedy conspiracy is constantly and cleverly, year after year, decade after decade, talking the ministers and managements into making really bad decisions about the architecture of their systems and digitalization. And I think anybody listening to this can read that and understand what it means. They want your money up front, even if they deliver nothing. Of course they do, and you would too if you're in their position. But we have to fight them by basically saying, look, if you deliver the value we want, can we pay you then? Oh, no. Why not? What's your real reason? Aren't you sure of getting the money? What if we paid you twice as much money if you delivered the value rather than just paying you for no value? What would that entice you? Okay. I mean, there's a really sick situation out there of suppliers. This is a military industrial complex collecting shitloads of money and delivering incredibly high percentage totally failed projects to the government and industry. And we don't have architects and designers mature enough and trained well enough to handle this problem and make sure that their businesses and departments get good value for money. The 12 tough questions are designed to be read by a top manager. I once printed these on the back of a business card and handed it to all my executive clients and acquaintances so they could start playing these little tricks on the suppliers during a meeting. It's quite fun. Now, there's a popular technique going the rounds in most countries. It's called design sprint. I'm guessing, I wish I could say how many people heard of that or start messing with it. The reason it's so wonderful apparently is that Google and Intel used it and they are successful companies. Therefore, everybody else should use it. I started examining it and I was not impressed. And this week that I'm showing you is my answer to it and replacement for it. Just for fun, here's the book by Jake on Sprint. I read through the book and I found no data about how it works and how well it works and what it costs. One example of a corporation which has now grown bankrupt, and I'm really not impressed if people can't tell me, for example, if they say it worked at Google or Intel, which projects used it and how do we know about cause and effect of it? And you're not going to find that information. I've taken a check on my inside sources at Intel, which in fact have been 20,000 engineers at Intel have been using these language methods for 20 years, and we have data on exactly how successful they are. And I've showed it in some of the courses and books, and we'll do in others. So just jokingly, I said that I've observed that Intel and Google, we've observed that almost all employees eat breakfast every day before going to work. And therefore, if you want to be as successful as Google and Intel, the method is that your employees should eat breakfast every day. That's just about as stupid as use design sprint, because they do. So this reason for using it, I mean, it may or may not be a good method. I personally have no reason to think it's any good whatsoever and no data on it. And I spent some time studying it. Here are some of the reasons why it's no good on the left-hand column. And if you want to compare, here are my claims for the methods I'm talking about, which are pretty well documented in writing in the books in detail. So I would like to think that everybody listening here is mature enough to not waste time on things like this that have no real claim to fame, and to at least study the claims here and try things out and measure and see whether these methods work or not. Here's just more of the same, my skeptical observations on design sprint. And here are some of the claims they make. And it's all management bullshit with, you know, no numbers, no reality, no credibility. I can't believe that people buy into this. But then they did the same with Scrum and Agile. We have a lot of people in IT that are so immature, they buy into simple-minded, simple-sounding things. But if you go into some detail, like what is the degree of success and failure of Scrum projects or sprint design sprint projects, you get another story there that the sellers of the methods won't tell you about. It's really sad that we have so many immature people amongst us, and I like to think that you who are listening are not of this ilk, and you wouldn't buy into these stupid arguments, and you'd ask for more evidence from me and anybody else about how do you know, why do you claim that your methods work. So here's just another round, a reminder of day one. This is actually British Computer Society workshop of the kind we were planning to hold, but coronavirus has stopped us, but we've held them earlier with the top 10 goals for cleaner air in London. And these are, and if we take one, air quality, here is in fact the quantification that my students and specification that they did, quite detailed, quite mature. We know a lot more about air quality by reading through this stuff than just saying good air quality is a nice idea and everybody ought to drive an electrical vehicle, and that's the end of that. Okay. Day two, here are the top 10 strategies. Here are their tags. At one point, I asked people to take the advanced congestion charges strategy and decompose it. Here's the decomposition, and hopefully get to a decomposition where one of these things can be done in a week or so, in a sprint at least, completely independently of whether I've done anything else, and I will get a measured and valued result. So these are, if you like, the sprint design level. This is the architectural level, the top strategies level. Okay. Again, I'm teaching this method of planning to British Computer Society students, some of whom might be listening in. Okay. Here's a detail from the London pollution planning. That was 2016. And here's one of the ideas called allergies best idea. That's this baby here. Okay. And here is the specification for that. And here is actually, the description is actually beginning to give us a breakdown where we can maybe find component sub-designs that we can do on one sprint at a time, but we haven't gotten that far. They have put this on an impact estimation table. I know that because it reveals a little information about that here and its impact here. That's bringing the table information as sort of a additional information to how good has this design idea shown itself to be, at least while we estimate it. Here is going back to here. Here's the advanced congestion charges idea, and it's broken down into design 1 to design 8 at my request. And so here's this top level strategy. Think of it as an architectural level. And I asked them to break it down manually into independent ideas that could be delivered on a sprint independently of all the others and would arguably give some measurable value to at least one of our values. So they've done this. We then digitized it, and each one of these then is a separate sub-design. And we click on this, in the tool, we'd actually get access to the details of each one of these. And we can use each, you'll see each one of these is also used in an impact table, as we'll show you in a moment. So here we have the top level view of London pollution planning. Here are some of the numbers for how good they're going to get. Here's some of the costs. Here's the top level things. There's the allergies best idea we said. Here's the top level of advanced congestion, but we're going to look at more the decomposition and decomposition of it shortly. But here are the top levels, and here we get the sums of how good are these overall in delivering, and what is their cost against our budgets overall. And the green numbers say this is the best value to cost idea. But with regard to credibility, this baby here, allergies best idea, actually is the best cost. And if we take worst case and credibility, this idea, clean air, etc., actually gives the best ratio. So the winner of designs depends on your degree of risk you're willing to take. Here is the same table converted to a bar chart with the value and the cost estimation. In other words, this number 171 and this number 2%. So there's 171 and there's 2%. But again, for management presentation, but we've also sorted it left to right. So the highest value to cost is first, sort of like these famous people sorted in sequence of height. There's Napoleon anyway, and I think it's Nelson Mandela. I had no idea he was so tall. And there's Abraham Lincoln. I knew he was as tall as that. So what we've done, we've actually sorted the spreadsheet so that the smartest thing to do with the lowest cost probably means you can do it in a small sprint, like a week or two. Maybe, maybe not, but once very low cost is often taking that into consideration. And then it gives pretty good value for money. And this gives far more value for money, but it looks like it costs, generally speaking, 4 times as much. So it might not be the smartest thing to do next week. Okay. So what we're doing is we're prioritizing the high-level architectures. And we could even, now if this low cost turned out to be a month, we might decompose this into 4 subsets and find things we could do each week. And but depends on whether you want it, we're okay with a month or you need to do it at a weekly level. Here's the an overview diagram of the stakeholders for the London congestion. There's the Mayor of London, there's the National Health Service. Here are the cost aspects here. Here are the top 10 values or requirements. There's air quality, for example, which we looked at in detail. These are the designs, okay, the bright ideas. Here's the advanced congestion charges, which was decomposed into sub-designs. Think of these as weekly increments, and this is one big architectural idea. So here you have, we've used the data we've collected to automatically generate a very nice overview chart when you're presenting things. Here is the day 3 value table. We've shown a few of these before, but here, this is the same example, the London congestion goals and resources. Here are high-level architecture, some of them, and here are the ratings of how good they are. This looks like a loser with so many negative side effects, doesn't it? We've got to look at it. And this looks like a winner, but this is almost as good. So maybe looking at how much they cost might be interesting. Here we take the same table and we automatically prioritize it. So in this case, the head of the queue, the first sprints, this is automatic product owner, if you like. It says, hey guys, the smartest thing for your team to do is do this one because it has the highest value to cost ratio. And then maybe we'll do all of that, maybe we'll do part of it, but the next major strategy is probably this one with all this value and not too much cost. And this thing here gives practically no value at higher cost than value. Probably we'll draw the line here somewhere and never do it. Okay, so this is famous people queue by height. Day 4, this is finding, this is decomposition or extraction. I used to think about this as just give me, don't worry about systematic decomposition and extraction. Just find me something I can do next week and get on with it. But I've later matured my own thinking and saying, let's decompose and pick one of these to do next week, and let's do it and get some experience. So because this decomposition takes an hour or 2, we found, you might as well get it done this week and get an overview, and using it build a table. So here we have the decomposition D1 to D8, and you'll notice D3, D2, D1. So that's this decomposition. And here we have an impact estimation table for the second level of thought, the decomposition, the looking at possible sprints, how much they impact the values. And this is simply the bar chart of the same thing. You know, what's this? D3 is the smartest thing to do in terms of value. We're not looking at the cost in this particular diagram. We're saying to heck with the costs. It's only a week or so. We don't care. Let's just get a whole lot of value and look good to the outside world by delivering value. Okay. So here we have, in a sense, sprint planning, advanced engineering sprint planning with numbers, with structures. And the product owner is actually automated, if you like. We have artificial intelligence saying, according to the numbers and our values, this is the smartest thing to do, so just do it. And the project manager, if there is one, or the team, if there isn't one, this is very similar to the teams at Confirm It. They're, you know, they just look at the numbers and say, the numbers tell us this is the smartest thing to do. Let's call this evidence-based management or something like that, or at least fact-based management. The fact is, these are our estimates and this is the smart thing to do. And day 5, we choose this one, and we've made our decision about what we're going to try out to do on the next sprint, and then we will measure whether we got anything like this. And if we get approximately what we thought we'd get, we say, we know what we're doing, let's continue doing it, let's do this in the second week. If, for example, we got something really much worse than this, we have to sit down and say, why did we estimate so much when we in fact got so much? Let's understand that, because anything else we do now is just random, and we could be very wrong on all of these. We obviously don't know what we're doing with the technology we selected, and hopefully we find some better way of doing this. We redesign the design specification to make sure, we say, we forgot to specify that you need to have an ingredient called salt and sugar. And we put the salt and sugar in, and then we get this, and we say, it wasn't that we had such a bad idea, but we forgot to include all the ingredients so that we, in a foolproof way, really got what we mentally were inspecting when we mentally thought that salt and sugar would be in the recipe. We forgot to put it in there, and the sub-supplier did not include salt and sugar because they didn't interpret our design specification that way. So in a sense, we're testing the clarity of design specifications and getting rid of the, it's in the head of the designer, it's obvious. And we test what sub-suppliers and small teams would do when they misinterpret our incomplete, poor design specifications, such as we find embedded in user stories in practice. Okay. Part 6. And what have we got? We've got 22 minutes, so I'd better, but we're, okay, accelerate a little bit. Got through the main stuff. If you're totally overwhelmed, you know, turn off the switch and catch the rest of it later, because I've got through the main points I'd like to get, which is things about doing things in a very structured and systematic way, and focusing your energy on the stakeholder values, not on writing code and doing user stories and childish things like that. Anyway, part 6 out of 8, decomposition. You all know the wonderful, lovely little story of how do you eat an elephant? And the answer is 1 bite at a time. So here we have an elephant I picked off the web. It actually was an elephant for components of an IT system. And the thing I observed when I brought it in just to have a funny little elephant decompose symbol was that very many of those decompositions were what I would not do and not train people to do. They did things which are nice to do, but if you ask a simple question, if you did them, how much value would go to the stakeholders? And the answer is probably no value for all those things I put question mark. They're just sort of waterfall model processes, okay? These things with a plus V seem to deliver some real value. So here we have a perfectly good example of our poor culture of understanding how to decompose things. And I try to teach people to decompose things so that everything you've decomposed to is a plus value and will give measurable values when you deliver them. Now, but now we have, this is like a top level decomposition. These are bad decompositions. We need to go back and find out. We need to integrate these work processes into something which delivers some real meat at the end of the day. And then we need to take some of the, but if this is like a 3-month project, then, well, although it does say extract a first service, and that's pretty good, then we need to decompose it further. And I thought this colorful little elephant here was the bite-size decomposition. And this may be 5 times more resolution or detail, as I showed you earlier in the examples of taking a high-level design and decomposing it into 5 or 10 times the resolution, so that we can do these 50 times. Let's just think of 50 as 50 weeks in a year. And this is, 50 weekly increments, and we're done with everything at the end of the year. And this is just the high-level architecture of the 10 major things we're going to do in order to reach our value levels. So here's a lot of text from the book about decomposition, but it's really quite simple. I like to get down to a decomposition level of weekly in general, except for extremely large long-term projects, 10 years, 10 billion quid, in which case I like to get down to about 2% of the 10 years or 10 billion quid. I like 2% increments. Why 2%? 2 things. I found you can always decompose into 2% increments if you try. That is value delivery increments, not construction increments. We'll get back to that later. And if you totally screw it up, the 2%, you've only lost 2%. So it's like a gambling strategy. I never bet more than $10 in roulette wheels in Las Vegas, and I never lose more than $10 no matter what happens. Okay, that's a true story, by the way. Okay. Okay. Now here's another concept. I need to looking at my timing here, which is 19 more minutes, and I'll use it for lecture, and then I will do questions at the end if we can hang on and do that, or not. We can do it by email. Here are some. Here's a basic idea. I've learned that the things like waterfall model thinking, and much of that has gone into Agile, in the form of sprints for Scrum, to take a very specific example, and user stories for another. And it turns out we're very, very focused on finding small steps, which are really just building a system or acquiring components. But in other words, writing code to do the user story would be a very simple example. Now, if you ask a simple example, if I plug that code in, which of my values go plus, increment, get better? And often the answer is nothing, nada. Okay, you have to do 10 more such steps before you begin to get anything to happen. You're now looking at Big Bang, not Agile. Okay, so I'd like to make a distinction between a step you take, which is building something that has to be built sooner or later, and doing something that, if done, will actually increase the value. And that distinction is non-trivial, and I have to spend a while on my courses showing people that they think in these terms. I want them to think in these terms. And here's a little bit of information about how to do that, but if I could use the next 20 minutes on it. We've learned a little trick, which is what I want to point out here. If you look at a kitchen and a restaurant, you'll find that they have the kitchen, a back room, and the restaurant, the front room, where we actually deliver food to the real customer. Okay, and what we found is if there's something you have to do which would take 6 months, well, I can't deliver that in a 1-week sprint, can I? So what we do is we say if it cannot be decomposed, we put it in the back room and we just start working on it. And when it's done at step 7, then we could theoretically deliver it and get value at step 7. Okay, in other words, if we prepare the desserts in the morning and they're all frozen in the fridge. They take 2 hours each. On 5 minutes notice, a restaurant guest can say, give me that lemon meringue, and in 5 minutes we deliver it, even though it took 2 hours to do here. So we make a distinction between building cycles and value delivery cycles. We want the value delivery cycles to be small and frequent, to deliver a stream of good results. This symbolizes stream of good results, consuming, unfortunately, a stream of resources. But we solve the problem of how do you decompose things that cannot be decomposed by not decomposing them, by putting them in the back room. And several of my clients have had great joy from that. Here's Philips of Holland is one client who's used that in very enlightening ways, and even pointed out, Tom, we not only have back room and front room, but we have such a large supply chain that we have a back room and front room in the back room. And this is real. So it's just a way of sorting the work. We in normal Agile, we don't make such distinctions at all. And I think this is the Agile bit. This is doing step by step and delivering value. This is a construction exercise which cannot always be broken down into small steps. But if you say, well, if we can't, we can't, we just have to wait. But when it's ready, even in the middle of the step-by-step process, then I can deliver it, even if it took 2 years in the back room to develop. That's the concept I want to get across to you. Back room, front room. Okay, now design decomposition, what I've found, and again, I have to really be short and summarize here, is that we can always find a value stream. That is, we can always find week by week or 2% by 2% things to do, even though some of what we have to do is architecture that takes a year to develop or a year to deliver, and we have to put that in the back room. But we can start the stream early. Next week is a great pleasure. We can continue the stream regularly every week. We can build a stream of value incrementing. This is the ideal of Agile as it should be. But you have to understand these ideas of decomposition to do it. And these are not taught, not documented in books. You show me where they're taught and where they're documented in books. I found I had to use my common sense to come up with what's going on here, and I still can't find it in other people's courses and books. But prove me wrong, you are welcome. Through the first 10 or so years of decomposing systems, to everybody's surprise, I wrote down a accumulated list of methods for decomposing when everybody says it can't be done. And this is my accumulated list of about 20 things. The first one I can do, the rest of them would take a lot more time than I have. But for example, I found that a lot of people give up and say it cannot be decomposed in the first 30 seconds. And they're wrong. And if I sit in there and said, give me a few more minutes to think about it and I'll show you it can be done, and then I do it, I say, the reason I did it and you didn't do it is I gave myself some more time to think about it and you gave up in your first misunderstanding. Okay, so the first rule is assume that Gilb's rule of decomposition will work normally, and don't give up in 30 seconds. Give yourself at least 5 minutes if you're a creative, smart person, and figure out how to decompose it. Okay, now that won't always work, so you need some of the other rules, but every one of these rules is actually based on quite dramatic decomposition, where my client said it can't be done, but we'd love to do it. And then we use these methods for decomposition. We actually held a British Computer Society course, and so here who's listening was the one who asked me to do it and monitored it on decomposition for one whole day. So that's how big the subject is. Some practical organizational tactics to find good increments. Let me summarize this looking at my watch. You can train people and give them knowledge of how to decompose and find good increments. Here's the content of the training course. People who are not trained, I found even intelligent, experienced people, they give up too early finding increments. They don't persist and say, we must find increments or we won't get good results in the short term, and our big project might fail. You've got to have the attitude, we are going to find our living stream of value delivery, and we're going to do that in the short term, and nobody's going to talk us out of it. By the way, if somebody says we've got a big project, you know, like Brexit or something like that, and we can't do it, and it cannot be done, I'll make you a bet that if you pay me £1 million, I will find out how to decompose anything you like in 1 day or less. How's that for a cheeky offer? Okay. By the way, I won't pay you anything if I can't do it in 1 day or less, but I'll take your money if I can. But if you really think it can't be done, then you have nothing to lose by offering me £1 million if I decompose it. And it may be the whole of Brexit, which is certainly worth £1 million of advice. Don't you think so? I have a chapter in my value planning book, which is a mere 700 pages. British Computer Society declined to publish the book on the grounds that it was too long. I hate to think somebody said don't publish the Bible because it's too long, but fortunately nobody did that. But I'll give you a free chapter on decomposition of a mere 60 pages if you want to go into depth about decomposition. And you'll find things like these are just some of the decomposition methods. And I've got a little bit more detail on it. Won't have time to get a lot, but I've already, I think here's an example of taking big architectural ideas, and this is student work at in Poland, where we've then decomposed it into sub-designs, which can be done individually. And we, as I showed you already, we can rate the value to cost of the sub-designs and get a queue of increments for scheduling what the development team shall do. I like Henry Ford's attitude. There are no big problems, just a lot of little problems, and nothing is particularly hard if you divide it into small jobs. And he was quite famous for what he did with his production processes, not least during the Second World War. I've been enjoying listening to on the History Channel recently. Okay, 9 more minutes. The scale parameters that I taught primarily in the value requirements course themselves give 3 levels of decomposition. If you have 10 scales, you've already decomposed by a factor of 10 for ideas to look for. If you have 1, 2, 3, 4, 5 scale parameters, you've decomposed the scale by a factor of 5. And if one of your scale parameters has 4 conditions, you've decomposed by another 4. I'll make a long story short and hope the smartest of you have already figured out what I'm saying. Scale parameters are an excellent tool for helping your thinking about systematic decomposition of IT systems so you can deliver the most critical things first. Got it? Hope so. Here's the Department of Defense example again. Even there, this is a factor 10 decomposition, and here is on the another factor of 5 decomposition of the architecture, allowing us to find one little 2% which of the effort, which might deliver us 200% of the value we wanted. And so we're using the table to circle in on a smart thing to do early, which we did in fact do, much to the delight of the major general in charge of the project, Palici. I have another method, which for fun, I call the 1-1-1-1-1-1 method, which just said for each of these ones is a type of decomposition. This is percentage increase. In other words, don't go for 100% of the value, but be happy with 1% rather than 0. You may have 500 stakeholders on a very large system, but satisfying the most important of them is a good idea. You may have 10 major values, but delivering something for one of them is a pretty good idea. You may have 52 weeks of your 1-year project, but doing something useful in a single week is a pretty good idea. You may have 500 functions in the system, but making one of them have much higher value is a pretty good idea. And there may be several designs for giving improved value for the stakeholder, etc. But maybe doing one design this week and making it work, which is exactly what we did at US Department of Defense, is a good idea. So that's the 1-1-1-1-1-1 method. Let's see what we got. My goodness, 6 minutes, 2 parts to do. Tell you what, I think rushing through this might be a bad idea, saying it's all in the book and I can give you a certain sample of it. So I believe there are that risk management can be done by design. And so this section is trying to give some advice on how the designer might look at risk. Let me make it really short. You can design systems to have lower risk. And that should be one of the talents of a designer. Design out the risk. Okay. Ericsson of Sweden had a wonderful corporate policy where they said that risk is the responsibility of every engineer at all times. It was a decentralized. They didn't say it's for the architect of the project. They said everyday work, there's risk in almost everything you do and every design you do. And some designs have a lot lower risks than others. And the designer can be conscious of this and design things that will work first time around probably, rather than taking unnecessarily high risks. So this is probably a good one-day course all on its own someday. We've done indeed at BCS a number of risk courses and taught these ideas, but I've been very specific in what those ideas are, for example, on this slide and this slide about risk design principles. So the last part, which is about we got 4 minutes and it gets kind of silly. We've talked quite a bit about prioritization on the basis of value to cost. And that's really the main idea I want to get across to you guys. And I couldn't do this subject justice in the time I have left. In the value planning book, I'm going to give you a free copy of about 60 pages, which is a very short book on prioritization, my style. But I'll summarize it. I prioritize by value to cost with regard to risk. Things like user stories and Scrum do not think that way at all. Check it out. And you can make up your own mind whether you think we ought to prioritize value of the stakeholders to costs, which are the limited resources of the stakeholders, with regard to risks, okay? And that the designer is in very full control of all of this. So I'm going to, that was the whole number 8. Number 9, I'm just gonna dramatically say, well, I'd love to tell you about that, but I'll do it another time and you can read it yourself. We'll skip organizing the process, but what I have there in summary is some new types of people, like a value process manager and a value designer and a value engineering specialist. I hope that tickles your imagination. These are, instead of having product owners and that kind of childish thing which you find in Scrum, until Scrum is enhanced with these ideas, as my friend Jeff Sutherland has publicly said they should be. So going into the home stretch, about 3 minutes left. Summary of value design. You must, in my opinion, otherwise you're a joke, quantify all critical stakeholders, critical values. That's your starting point for design. You need to understand quantitatively your resource budgets, short-term and long-term, like technical debt and other constraints. You need to design consciously to reach the value levels that you have specified that your stakeholders want for success. You can decompose designs into small, implementable, value-giving design components. You need to measure how well these value increments work for giving value and what they cost, and learn when they're not working and learn when they're working so you can scale up. You need to adjust your initial designs when they're not working so that they work better in practice. And the case study I skipped over of clean room at IBM is an excellent example of doing that on a very large scale for space and military projects. So I commend the clean room case, which I skipped at the end, to your attention. So now notice that I'm 1 minute before what my watch says is the end, and I'm at the end. And the reason is I did design to cost when I wrote the slides, and I did deliver to cost when holding the talk. In other words, I'm practicing what I preach, so I get done with fairly high quality on time. I'm proud to be an honorary fellow of British Computer Society, and I hope to serve. I'm only soon 80 years old, so another 20 or 30 years I hope to serve. And even when I'm an old man living at my old age home in Norway, I hope I can hold talks and courses like this and inspire your grandchildren if I didn't manage to inspire you. The slides are here and the video will be here, which is the SPA video thing, and it has the video for the value requirements. So I'm done, and it's 10 o'clock.
Before you go, Tom, we have a question.
Yeah, I'm ready for questions.
I've opened the microphone for Mark to talk if he wants to. He's asking about long-term thinking or architectural principles. Mark, would you like to
Tom, I hope you can hear me.
I can hear you clearly. Yes.
Excellent. I was thinking about long-term architecture principles, which I don't think you've covered. I completely get agile architecture and breaking down the problem and breaking it down to small parts, but it's the overriding grand concepts of the architecture in terms of where are you heading. Do you see value for that?
Yes. Now, I believe that I did talk about it, but obviously not so you recognized it. Now, if you go back to, for example, the US, by the way, people are talking in the background and I'm not hearing them. Here. Is it my turn to talk? I hear talking in the background, so did everybody stop talking? Mute their mic. Somebody's talking. Can anybody hear me? Okay. Now, take this example from the US Department of Defense. You see these things, technology, investment, business practices. These are the long-term high-level architecture of the US Department of Defense. So I am talking about the long-term architecture, and the short-term architecture are the decomposition of these. For example, exactly which business process re-engineering processes we're going to select in order to get this 200%. So the simple answer is, believe it or not, I am and have been talking about long-term high-level architecture. If that's not clear, review it with what I've said, where I'm claiming to do that. And if that doesn't work, feel very free to email me or get me on a FaceTime or Skype call, and we'll discuss it more.
Okay, Tom, that's great. I'll take a look. Thank you.
By the way, can you identify yourself? Who asked the question?
It's Mark here, Mark Renton. I work down in a small insurance company.
Okay, Mark Ransom, I know the name. So we can talk about it by email if it didn't help.
Okay, thanks, Tom.
Pleasure, thanks for attending. Any other questions we want to do, Evo?
I'm seeing lots of questions coming up, but basically they're just saying thank you very much and giving you applause.
Oh, give me a copy of it.
Thank you very much.
Thank you.
Thank you. Still here?
Dave Mizell was asking about a 101 on downloads. Are you having a problem, Dave?
That's okay. Dave knows how to email me 3 times a day, as he did today. So that's fine.
He's asking questions every 10 seconds during the talk. So.
Yeah, that's fine. I'm happy to. I talk with Dave all the time.
Great stuff. Thank you very much, Tom, and we'll release you from this ordeal. Look forward to the next one in a fortnight's time. Thank you very much.
Yeah, and the subject will be value management. So I'll look more at the project management and up level is what's going to happen. But the
can I add?
Yes, go ahead.
Well, can I add in Margaret Ross on behalf of the Quality SG? Thank you very much, and for actually letting us join in with your webinar. It was fantastic. Every time I hear one of your webinars, I learn more than I'd actually from extra things. And can I just add on that as your honorary FBCS, there is actually only approximately, I think it's about 115 since the start of the BCS. So it's you're very rare and very appreciated.
Half of them probably are no longer with us. But I'll hang in there for another
with us for a long time yet. Okay, thank you very much. Look after yourself. Enjoy a cool beer or something.
Take care.
And don't forget that you can share this, the book, the slides, and the video with friends. Don't be afraid to put it on the internet and share it with friends.
That's very generous.
Thank
Bye-bye.
you.
Bye-bye.
All the best. Bye.
Bye-bye.